On one ordinary October day, the 25th of the month, when the sun had long risen above the horizon and was shining with its bright, warm light, something happened that shook everyone who follows unusual phenomena in our solar system. Against the backdrop of the quiet, calm activity of our main star, which for several weeks showed signs of extraordinary serenity, three mysterious objects suddenly appeared near it, in a place where they had never been before. These three unidentified bodies appeared unexpectedly and immediately drew the attention of those who closely monitor cosmic events, as their appearance was so unusual that it was hard to believe it was a coincidence. The objects were observed near the Sun, close to 3IATLAS, an area known as one of the brightest and most active regions of the solar corona. And what is especially striking, these three enigmatic bodies appeared at the very moment when our star, usually calm and balanced, suddenly woke up and shone not once, but 3 times, as if reacting to the approach of these unknown objects. The entire phenomenon was recorded on camera, and the footage, captured with amateur equipment, caused a real sensation among those monitoring solar phenomena. They moved with precision and grace that seemed unreal, as if created according to a premeditated program. Their trajectories were so flawless and coordinated that it was hard to believe in their randomness or natural origin. These objects did not resemble ordinary space debris or meteors moving chaotically and aimlessly. Their movement was smooth, precise, as if someone was directing their motion, planning each step. And despite all this, at that moment, there was neither sound nor signs of any official response or explanation. No scientific or space organizations issued any comments, no loud statements or headlines on front pages or news feeds, as if the event was deliberately concealed or completely ignored. This raises the question, why hide it so much? Perhaps authorities and scientists decided it was better to keep everything secret, possibly hoping that no one would notice or understand the scale of what was happening. Or maybe they believed that revealing such secrets would be dangerous, as it could overturn our understanding of reality and what truly happens beyond the visible. In any case, such silence looks suspicious, and it only heightens interest and the desire to uncover the truth. Today, we will embark together on an investigation of these hidden data, flipping through the pages of forbidden information, and by the end of our journey, you will learn about the most dangerous and mysterious secret in modern astronomy, which remains the most relevant and alarming to this day. Part 2 of 64. If this topic continues to trouble your mind, preventing you from sleeping peacefully at night, as it does for me, I strongly recommend that you pay attention to all these facts. Remember the importance of staying informed and trying not to miss any new information. This will help you better understand what is truly hidden from the eyes of ordinary people. In the future, to avoid missing anything important, it's worth considering preserving this knowledge, sharing it, and discussing it, because only in this way can we help uncover the truth. In the comments, share where you are watching this video or reading this text from, tell us what time it is on your clock, and share your thoughts on whether we are really being told the whole truth or if something much more important and dangerous is being kept secret. If you want to support this project and help us continue our work in uncovering hidden secrets, share this information on your social networks, participate in groups, and discuss it with friends. All of this gives us the opportunity to continue research that most would prefer to keep in the shadows because it might threaten the established order. This community is created thanks to you, thanks to your interest and desire to know the truth. Now, let's imagine a scene as if we are observing it. Their synchronicity undoubtedly suggests some kind of special coordination and interconnection between them. When the well-known scientist Chiagu first published his conclusions and hypotheses, he called these three objects that appeared near our solar system, satellites, or even dark matter, which, in his opinion, lies beyond the 3 known interstellar objects called atlases. These 3 mysterious bodies arrived in our vicinity from the depths of space, and their appearance coincided with the arrival of the so-called 3IATLAS, large interstellar objects that, according to recent data, were discovered and recorded at the end of the 20th and the beginning of the 21st century, that is, in the late 2000s, and to this day remain a subject of debate and research. The appearance of these 3 new objects caused a real explosion of interest and a storm of discussion in the online astronomical community. Discussions and debates flared up online, and at this point, the entire story takes an unpleasant turn for official science. The fact is that the statistical probability that three independent objects, appearing almost simultaneously, would cause three separate solar events, namely, three powerful explosions or flares, is so minuscule that, if one tries to explain this using traditional probability theory, any rational and scientifically oriented person would consider such coincidences to be mere chance or randomness. But we are not talking about simple and unlikely events here. We are talking about something much more unusual and alarming. A situation that makes us stop and consider possible hidden reasons, wondering if there is something more important and significant happening beneath the surface of these events. Three objects, three explosions. Each of these events is associated with powerful energy releases, and all of them occurred within a very short period of time. The pattern emerging from these events seems too clean and clear. The timing of their occurrence is precise to the second. The coincidence appears too perfectly orchestrated, as if someone deliberately arranged everything to make it look flawlessly synchronized. In any field related to data processing and analysis, it is well known, such patterns do not arise by chance. They occur because someone or something is driving, controlling, or pushing them. And this is precisely what causes deep skepticism and suspicion among experts. However, after these three events took place, a profound silence followed. No official comments, no press conferences, no statements from leading space agencies or scientific institutions. The whole world observes this silence as if waiting for someone to provide an explanation. The institutions responsible for studying our solar system, those that should clarify and shed light on the situation, simply remained silent. They made no statements, offered no official explanations, and published nothing in scientific journals. In a world where every new discovery immediately receives widespread coverage, where the detection of new exoplanets, gravitational waves, or other cosmic phenomena quickly becomes sensational news and headlines, these images of three mysterious objects went through all official channels of information and encountered what can only be described as institutional silence. This silence, like a black hole, absorbs all information. It itself becomes a kind of statement, raising new questions. Why, of all organizations with modern observation tools and research potential, organizations with thousands of scientists, engineers, and specialists, did these institutions choose to remain completely silent about such an important and undoubtedly unique event? Why, possessing full data and the ability to monitor all aspects of solar and space phenomena, do they ignore the appearance of these mysterious objects, an event that clearly contradicts our most fundamental notions of what is possible in the near-solar space and in our overall understanding of the cosmos? The occurrence of these events raises a whole series of complex and multifaceted questions regarding the possible consequences, which are difficult to predict and fully understand, since no government or scientific institute is currently prepared to give definitive answers. Part 4 of 64. These questions concern not only the legal and military spheres but also touch upon fundamental existential aspects of human existence and its place in the universe. In conditions of complete silence, which in many cases is the only means of ensuring safety, one might attempt to hide by pretending that nothing unusual has happened, that everything remains within familiar boundaries. However, such silence creates a certain vacuum in which various conjectures form, conspiracy theories emerge, and a flow of disinformation spreads, either intentionally or due to oversight. A more rational and honest approach in the current situation would be to openly acknowledge and recognize what has been recorded and thoroughly analyzed by specialists. This would mean not hiding the obvious but actively sharing facts and investigation results. Instead, we face a situation where the existing scientific community avoids raising the most important questions, sidestepping discussions of possible hypotheses that could radically change our understanding of the world. Among these is the question of whether what happened could be the first publicly registered case of kinetic intervention in the physics of our Sun. It is possible that we are witnessing in real time the first contact between humanity and a form of intelligence existing beyond human comprehension. These questions do not rest easily. They keep us awake at night because their outcome is critically important for the future of our civilization. All of this begins with the mysterious 3 objects and 3 explosions, about which none of those in leadership positions or with relevant authority are willing to speak openly. The second part of this reflection relates to how we perceive images, whether they contain hidden information or if we are simply observing mechanisms of concealment of true intentions. Probability is a harsh mirror reflecting our assumptions and weaknesses. And if we recall the events associated with the so-called 3 atlases, some things become immediately obvious. If 3 separate objects entering the near-Sun space independently cause powerful solar eruptions, and if all this happens by chance, then the probability of such a coincidence is roughly comparable to drawing the same ace of spades from a deck of cards 500 times in a row. Of course, this is not impossible, but the likelihood of such a scenario is so low that assuming it is purely coincidental becomes almost impossible without deep ignorance or deliberate denial of facts. The human brain is wired to recognize patterns, which is why we have survived and evolved as a species. We instinctively pay attention to patterns. They help us detect predators or prey, and therefore, recurring scenarios evoke particular interest and require analysis. The 3 explosions following the 3 object passes are not just noise or coincidence. This is a signal that cannot be ignored. Yet, at this stage, the scientific community often retreats, going into defense mode and asserting that correlation does not equal causation, that extraordinary hypotheses require only compelling evidence for confirmation, and that skepticism is an essential part of the scientific method. Yes, all of this is true. Skepticism is necessary. It helps avoid mistakes. However, it can also become harmful if it turns into a pathological stance that dismisses or rejects any data contradicting established theories. When we reject facts simply because they do not fit our preconceived notions, we cease to be objective and become dogmatists. In such cases, we are defending our theories from reality rather than serving the pursuit of truth. Sabine Hosenfelder, a physicist with extensive experience, warned about this, publicly stating that denying the possibility of artificial origins for observed phenomena without thorough investigation is the greatest mistake civilization can make. And this mistake is not. In the distant 1940s and 1950s, military specialists encountered phenomena that no one could explain, unidentified objects and manifestations that did not fit into existing models or conventional ideas about airspace. At that time, to preserve secrecy and prevent the world from learning about these unknown and potentially dangerous discoveries, authorities decided not to publish the information openly. Instead, they classified all data, divided it into categories, created strict storage systems, and kept everything in complete secrecy, conducting investigations in an entirely closed manner. For many years, about 7 decades, this secret remained classified as top secret, and society remained unaware of the scale of what was happening. Why should the situation be different now? Why should we believe that hiding something important occurring in near-Earth space will continue to be effective? The answer lies in the fact that independent researchers and astronomers continue to receive confirmations that do not fit conventional frameworks. In recent years, more and more data have emerged indicating the presence of unusual objects and phenomena in the sky that were previously unnoticed or ignored. For example, Night Monkey, a group of amateur astronomers, documented the appearance of fast-moving signatures, objects that appeared in different parts of the sky and moved in ways inconsistent with typical comet or space debris trajectories. These objects exhibited movements that could not be explained by standard astronomical scenarios, and their appearances did not align with conventional orbital characteristics. Additionally, other amateur astronomers using publicly accessible platforms, such as solar and space object observation systems, have identified further anomalies that the broader scientific community often did not even suspect. These observations confirm that we are witnessing not isolated cases but a growing stream of evidence indicating the reality of phenomena once considered merely fantastical or unlikely. Today, we are dealing with an accumulating body of independent proof that highlights the existence of something significant, something that can be measured and documented in data. Yet, these facts remain outside official narratives and interpretations. So, let's try to understand what we can and cannot do in a situation involving unusual observations and our reactions to them. The most important thing we must not do is simply pretend that the anomalies recorded by independent observers do not exist at all. Ignoring them means consciously turning a blind eye to facts that causes discomfort or confusion. We cannot afford to remain indifferent when clear evidence points to something extraordinary. Silence in such a situation becomes complicity, because refusing to acknowledge or discuss these facts undermines our own honesty and scientific objectivity. Ultimately, it becomes a kind of choice. Either we accept the existence of anomalies and seek explanations, or we continue to conceal them under the guise of good sense. And this choice is not merely a matter of personal opinion but an expression of institutional corruption disguised as scientific responsibility and a mature approach to study. The pattern, which becomes more apparent upon careful examination, is increasingly evident. We are dealing with three objects, three explosions or flashes recorded by three independent observers, each of whom documented the same event within the same time frame. These observations are documented, and although the evidence appears ambiguous, they still point to something significant. This is not a subtle phenomenon hidden in noise or distortions. It is clearly visible in our own data. And we are all waiting for someone in positions of power or with scientific authority to simply admit, yes, this truly exists. But the question of timing and correlation, of the connection between events, is only the tip of the iceberg. When we begin to question the very nature of light, its essence, the mystery deepens and becomes even more enigmatic. We need to study not only light itself but also polarization, a phenomenon capable of revealing much about the composition and origin of what we call the atlas, or, more simply, about the material from which observed objects are made. This is the third part of our topic, dedicated to the polarization paradox. Light propagating through space behaves like a wave. It oscillates. Under normal conditions, these oscillations occur in all directions perpendicular to the direction of the light wave, like a stone thrown into a calm lake, creating ripples in all directions. Such chaos of movements is the norm for ordinary light. However, the situation changes when light encounters various obstacles, dust, ice crystals, or complex surfaces. Then, something remarkable happens. The wave oscillation becomes more organized. It begins to predominantly oscillate in one or several specific directions. We call this phenomenon polarization, a special state of light in which its oscillations are confined to a particular orientation. And this polarization is extremely sensitive to the physical properties of the objects through which the light passes or reflects. It reflects their structure and composition. Scientists have been using polarization analysis for decades to study comets and other cosmic objects. They know what patterns emerge when light passes through the dust shells of comets and how these patterns help determine the composition of particles. For example, it is known that ice grains polarize light differently than silicate minerals or dust particles made of other materials. Based on this, a specific catalog has been developed, a basic model that describes the behavior of ordinary comets when sunlight passes through their dusty clouds and reflects back toward Earth. This model serves as the foundation for comparing and interpreting observations. However, when we analyze the so-called atlas, or more precisely, objects similar to the 3IATLAS, the situation changes dramatically. These objects differ so significantly from the expected standard characteristics that researchers analyzing them have been forced to publish their conclusions in articles filled with disclaimers and expressions of uncertainty. The ridges observable on the surface flow in such incorrect and unexpected directions that they create complex, tangled patterns. These patterns, in turn, do not resemble the usual appearance of human anatomy or natural forms. If we encountered such an image, we would immediately suspect that the fingerprint is a forgery, a manufactured imprint created artificially. Or we might think that we are looking at a person whose biological structure differs radically from the familiar human norms. Such conclusions can be drawn from the polarization data analysis. These data indicate that the surface of the third atlas is composed either of materials not typically observed within the solar system or of materials whose structure and texture have no known analogues among familiar objects. In both cases, we are dealing with something unusual and currently unclassifiable by conventional standards. Naturally, this raises the question: what material or structure lies behind this image? If it is not ordinary dust, then what exactly is it? It is possible that these are exotic ices or artificial materials created using technologies beyond our current knowledge. Perhaps the surface contains special materials with unique reflective properties, which cause such unusual polarization effects. As a hypothesis, most researchers have proposed a model in which the surface of this object consists of dust gas and particles similar to those forming comets. This suggests that the third atlas is almost entirely composed of solid material, dense, heavy particles with very few gaseous components. The dust from which it is made is larger and heavier than typical cometary dust. Such a composition could explain the absence of characteristic spectral signatures usually associated with comets, as well as some anomalies observed in polarization. These anomalies are most likely related not to chemical composition but to particle size and density. Overall, this hypothesis appears quite plausible and scientifically justified. Moreover, it is very convenient for explanation. It does not contradict existing notions about the cosmos and does not require a revision of fundamental theoretical principles. As a result, the third atlas remains classified as an unusual natural phenomenon, albeit with some unexpected features. An astrophysicist named Loeb, who tends to consider hypotheses of artificial origin for this object, estimates the probability of a natural explanation at about 4 out of 10. This means he believes there is roughly a 40% chance that such a structure or phenomenon is the result of natural processes. At the same time, he assigns higher odds, 6 out of 10 or even more, to the hypothesis suggesting a more exotic and possibly artificial origin. When hearing such assessments, it is important to pause and reflect. The statement by the scientist from Los Standings that the more probable explanation is an unnatural origin does not equate to a firm belief in the existence of aliens or their involvement in the formation of this object. It is more a recognition that the anomalies are so serious that traditional, familiar explanations seem less plausible. In other words, he suggests that most specialists in cosmology and astrophysics, honestly analyzing all data, tend to conclude that a natural explanation does not appear convincing. This trend is evident at every level of investigation. All evidence points elsewhere, and existing models attempt to conceal or ignore it. Meanwhile, the institutions responsible for studying such phenomena remain silent, and light passing through these objects refracts and reflects in ways we still do not fully understand. As a result, we face a surface or structure that defies our usual categories and concepts. The very fact, manifested through the polarization of light, indicates a physical property of the three atlases that contradicts our preliminary assumptions about the nature of such objects. Spectroscopy is essentially a unique tool that allows for something akin to cosmic forensic analysis. Imagine, when light originating from space passes through interstellar matter or reflects off it, it does not simply change color or brightness. Every component, every chemical element present in this matter, leaves a characteristic trace on the spectrum, very similar to a fingerprint burned into an image. These fingerprints are specific lines that create particular waves and absorptions in the spectrum. For example, nickel produces its own unique line, easily recognizable and identifiable. Iron is another element, with a spectral line that differs from nickel's, and cyanide is yet another component, leaving its own distinctive mark. Scientists diligently cataloged these spectral signatures for each element in order to accurately determine what exactly is present in a given region of space, its quantity, and how these elements are distributed within that matter. Thanks to this knowledge, when scientists observe a spectrum obtained with powerful telescopes, they can make precise inferences about the composition and makeup of substances located millions or even billions of kilometers away. One day, when the KEK Observatory, one of the most powerful and advanced telescope facilities on Earth, directed its instrument at 3 different astronomical objects and recorded their spectra, a truly revolutionary event occurred. The data collected from this observation revealed emission lines belonging to nickel. And this was not just interesting, it was a real shock, because the detection of nickel lines in space is by no means surprising in itself. Nickel is found in comets, and its presence in interstellar objects is not uncommon. But what truly astonished scientists was that the spectra showed no lines of iron, or more precisely, they were so suppressed that they appeared almost absent. Moreover, the ratio between nickel and iron recorded in the data was many times higher than in any known comet or celestial object previously studied. This was not just unusual, it contradicted everything we knew about the formation and evolution of objects within our solar system and beyond. This contradiction was so evident that it was hard to dismiss it as a coincidence or an error. But the astonishing discoveries did not end there. When considering also the ratio between cyanides, the situation became even more complicated. Cyanide emissions are quite common in space, especially in comets and other small bodies. They appear in almost all such objects and are considered standard. However, the spectra obtained in this study showed an extraordinarily high ratio between nickel and cyanides. It was so extreme that, if someone tried to interpret such data as the result of natural processes without additional hypotheses, it would only provoke ridicule and mockery from the scientific community. Because such ratios are entirely unusual and virtually impossible under natural conditions of interstellar object formation. Nevertheless, these data were collected, recorded, and published by researchers from the KEK Observatory. The scientists presenting these results faced a reaction. Most scientists either ignored them, considering the data potentially erroneous or too extraordinary to be taken seriously, or attempted to explain them using existing models, such as the Pystry model, which assumes certain processes and conditions for element formation. But it is precisely here that industrial chemistry comes into play, and the situation takes on a completely different, more alarming tone. One of the key compounds that draws particular attention is nickel carbonyl, a compound that is extremely rare in nature and is known only through human-made technological processes. In industry, it is used in metallurgy, specifically in the extraction and purification of nickel on a large scale, where it is produced by reacting carbon monoxide with metallic nickel at certain temperatures. It is crucial to understand and accept this as an undeniable fact. When dealing with unusual chemical anomalies, extreme caution and strict critical analysis are necessary. One cannot immediately conclude the existence of extraterrestrials simply because some unusual chemical feature was found in the images. Science does not work that way. It requires collected evidence, thorough analysis, and consistent conclusions. In such cases, a well-known phenomenon comes into play, confirmation bias, where a person tends to notice only those facts that support their hypotheses, ignoring all others. In these situations, it is very important to keep multiple hypotheses in mind simultaneously. For example, the presence of nickel in the samples can be explained either by natural processes, such as the formation of deposits through mineralization and interaction with various substances, or by deliberate actions, separation and special treatment of materials to achieve a specific composition. Both options remain plausible, as both hypotheses are supported by the available data. The question is not which one is true, but which has a higher probability and what additional research needs to be conducted to favor one version over the other. What is especially disheartening in this situation is the silence from the leadership structures and scientific institutions. The next logical step in the investigation is clear. We need more precise spectroscopic data, more detailed and high-resolution measurements. We must obtain not just general information about the sample composition but also understand where exactly in the sample the various elements are distributed, in what physical configurations they exist, and how they are arranged within the structure. This will help determine whether there are any unique or unusual element distributions indicating unnatural origins. Additionally, isotope ratios need to be studied. These ratios can provide valuable information about the origin of the elements, whether they arrived from the interstellar medium or are the result of processing stellar materials, that is, from stellar nuclear processes. Such analysis will help determine whether these elements were introduced from outside or formed within our system. A comparative analysis with other interstellar objects observed over the years is also important. This will help determine whether similar relationships occur elsewhere or are unique to this particular case, in the 3IATLAS. All of this represents quite logical and reasonable directions for investigation that any well-funded and competent scientific team should be pursuing right now. However, surprisingly, very few resources are allocated to these studies. Only a small number of articles are published, and almost no discussions on these issues take place at major astronomical conferences. It gives the impression that the scientific community has collectively decided not to take these questions seriously. And then a natural question arises. What exactly are scientists defending by avoiding discussions and further research in this area? Chemical analyses indicate something artificial or, at the very least, something fundamentally anomalous, unusual for natural processes. But chemistry alone is not enough to draw definitive conclusions. It is also necessary to study the physical structure of the three-atom atlas itself on raw images of its core. After all, what we observe in these images could open entirely new horizons of possibilities and hypotheses. Moving on to Part 5. This section concerns the structure of the scythe and the pyramid. Unprocessed images obtained by the Gemini telescope tell a story that goes beyond simple spectroscopic analysis and polarization measurements. These images touch upon a domain that causes particular concern among skeptics. At the highest resolution, the core of the 3IATLAS comet looks very different from most comets. Usually, we are accustomed to seeing asymmetrical, irregularly shaped bodies that resemble potatoes, which seem to result from chaotic processes. But in the images taken with the highest resolution, something else was recorded. Objective observers reported that in the center of the comet, they could see something described as a pattern resembling a stingray, a marine creature with a long, curved back and fins. This is not a coincidence or the result of chance. Objects we observe in space are often distorted and deformed by atmospheric turbulence and other factors related to the imaging process. The most obvious manifestation of this is the appearance of artifacts, distortions that alter the true shapes and details of objects in the images. These artifacts do not occur randomly. They are the result of complex and often unpredictable processes occurring during image formation. All these factors leave an imprint on the final result, making it not always completely accurate and unambiguous. The human brain is, by its nature, a unique pattern recognition machine, developed over hundreds of thousands of years of evolution. Thanks to this ability, we can detect hidden meanings, intentions, and plans in the surrounding world, even where they were not initially apparent. We tend to see faces even in clouds, interpret random patterns as signs of conspiracies and secret plans, and turn coincidence into something meaningful. This skill undoubtedly serves our survival, making us more attentive and sensitive to potential threats or important signals. At the same time, this very tendency to find meaning in random phenomena can lead to serious errors, especially when it comes to scientific data, particularly astronomical observations. Nevertheless, the question of the shape and morphology of cosmic objects remains very important. Imagine an ideal spherical asteroid. Its shape could indicate an unusual formation process or specific conditions under which it was created. And if an object had the shape of a perfectly regular cube, it would provoke even greater surprise and questions. What could cause such an unusual form? Ultimately, the shape of a celestial body is not just a random appearance, it contains valuable information. It is precisely the shape that allows scientists to infer mechanisms of its formation, natural processes that created it, or even, if signs of artificial origin are suspected, possible intentions. The debate over the morphology of mysterious objects, such as, for example, unusual figures depicted in space images, is not an abstract discussion. It is a real, tangible fact confirmed by multiple observations. Different researchers, using various telescopes and observing these objects at different times, have repeatedly reported the presence of geometric elements in the images, recurring and creating the impression of certain symmetry or structural features. These reports are not isolated or accidental, they can be considered evidence of serious observations. They are made not only by amateurs but also by professional astronomers who are ready to confirm their findings with their own eyes or recordings. The issue here is not whether these people are lying or experiencing hallucinations, but rather, how they interpret the data they receive. Because when analyzing ambiguous images, it is easy to fall into the temptation of seeing what one would like to see, that is, anomalies or signs of artificial origin, even if real indicators are absent. The broader context into which this entire picture fits is more important. In early 2025, reports emerged about unusual events related to unofficial meetings of top military leaders of the United States held in the city of Quantico. These meetings involved generals and operators managing the Naval Radio Telescope. The official version of these events is that they were regular briefings on space weather, solar threats, and related risks. However, the timing of their occurrence raises certain doubts, as these meetings took place immediately after intensive observations of three mysterious objects, so-called atlases. They involved specialists with access to data unavailable to civilian astronomers, namely, radio telescope operators who can receive and analyze non-optical data indicating the properties of these objects. High-ranking military officials were present at these meetings, which suggests either an extraordinary level of concern or a particular degree of awareness. Nevertheless, artificially created objects, whether man-made or resulting from deliberate design, usually exhibit entirely different patterns in their forms and structures. They display characteristic angular facets, sharply defined lines, and geometric shapes, as well as configurations that seem optimized for specific purposes. Such architecture clearly reflects a design carefully thought out and implemented for a particular function. When observers record images showing scalloped and pyramidal formations, for example, in photographs or images taken with the 3IATLAS system, they naturally question whether these shapes demonstrate properties of artificial structures created by humans or their equivalents, or whether they are natural bodies that have arisen in nature. These forms appear so unusual and complex that they immediately cast doubt on their randomness. However, due to the low resolution of the images and the presence of noise, it is currently impossible to accurately determine their true nature. Nevertheless, it should be noted that the patterns observed by many researchers and witnesses are so consistently and systematically manifested that it is difficult to dismiss them as hallucinations or accidental perceptual errors. These signs point to some underlying reality that requires confirmation through higher quality data, higher resolution images, and more thorough observation. We must acknowledge that understanding the true nature of these objects requires moving beyond simple visual perception toward a deeper analysis of what they might actually be capable of. In this context, it is important to consider that the 3IATLASes we observe are most likely not traveling alone. They may have satellites, smaller objects or devices moving alongside them for some reason, remaining part of their system. This opens new horizons for understanding their behavior and purpose. Moving on to the next aspect, it is worth paying attention to three objects that were recorded and documented by Chiagu even before the known solar eruptions. These objects raise questions that border on the realm of science fiction, yet it is important to remember that they truly exist, are confirmed by official data, and contradict all our current models of nature and the possible behavior of objects in the near-solar space. If we assume that these three objects are intentionally accompanying the 3IATLAS, if they are somehow connected to or controlling them, then the question arises: what are they actually doing? What is their ultimate purpose? Chiagu himself suggested that these objects could serve as satellites or companions performing certain functions related to the main body, the 3IATLAS. But what exactly is their role? The most obvious and simplest explanation seems to be the protection hypothesis. Perhaps these objects act as a guard perimeter designed to shield the main object from potential dangers. They could serve as a shield, creating a security perimeter, essentially functioning as security or sentinel elements, defending the 3IATLAS from external threats, whether cosmic dangers or something else. The idea of protection appears quite logical, especially if we consider these objects as something akin to military convoys deploying defensive measures around valuable cargo. In this analogy, the 3IATLAS are undoubtedly a very important and valuable resource deserving special attention and protection. To safeguard it, not only satellites but also a whole complex of auxiliary objects might be employed to ensure maximum security. In this case, the presence of additional elements accompanying the main object seems justified and even necessary. However, one cannot exclude the opposite viewpoint. What if these accompanying objects are not guards at all, but rather attackers? What if their role is not protection but destabilization? It could happen that these objects, for some reason, are working against the 3IATLAS, trying to disable or manipulate them as they pass through our solar system. In such a scenario, solar eruptions and activity are a remarkable phenomenon that causes shock and surprise. However, in terms of its unexpectedness, it does not surpass the idea of protection through escort. Ultimately, both options remain hypotheses, as they are based on limited and incomplete data. Nevertheless, both scenarios raise the same important and exciting question: are we witnessing the initial steps of a cosmic confrontation, which, for unclear reasons and circumstances, has crossed the boundaries of interstellar space and is now unfolding right at the edge of our solar system? At the center of attention is the very starry arena where this drama may be unfolding, with the three-eyed Atlas acting either as a ghost, a target, or perhaps as a reward for someone or something. The hypothesis that solar eruptions could be triggered by external influences is becoming increasingly testable, provided we carefully consider how this might work in practice. Specifically, if accompanying objects or celestial bodies actively affected processes within the Sun, we could expect to see recurring patterns in the manifestation of solar eruptions. This idea implies that as such objects approach the solar surface and pass by it, we should observe an intensification and correlation of activity. We would also assume that these events occur with a high degree of synchronicity, so precise that they could not be dismissed as mere coincidence but rather as evidence of deliberate interference or even an attack. Furthermore, a certain symmetry in the manifestation of solar eruptions might be expected, especially in regions of the solar surface that directly intersect the trajectories of the accompanying objects. These ideas were confirmed by observations from Chiago, who recorded some of these events. For example, the triple coronal mass ejection, dubbed the Cannibal, scheduled for the end of January 2025, demonstrated the very temporal correlation one would expect if external influences truly provoked eruptions on the Sun. However, despite these supporting data, just 3 observations are insufficient to draw definitive and unequivocal conclusions. We need to continue monitoring and analyzing what is happening to understand how 3IATLAS, the provisional name for this object, behaves as it approaches perihelion, the closest point in its orbit, which is in direct contact with the solar surface. The mechanism by which such an initiation of solar activity could occur warrants separate attention and careful consideration, even when discussing hypothetical possibilities. One possible scenario is the idea that solar magnetic reconnection, an active and ongoing process, could serve as a kind of trigger mechanism. The Sun's magnetic field is constantly restructuring, tension in its magnetic structures accumulates, energy gradually concentrates, and eventually manifests as solar eruptions and flares. However, the timing and location of these eruptions are determined by complex dynamics that are not yet fully understood or studied, making precise prediction difficult. Now imagine an external object with an unusual charge or a unique composition approaching the star's surface. Its presence in the Sun's magnetic field can cause disturbances, leading to local changes in the magnetic topology. These local disturbances may serve as the final trigger that converts potential energy into kinetic energy, resulting in a large-scale eruption that would otherwise be inevitable. However, the exact timing and location of its manifestation could be significantly influenced by external factors. This is not magic or anything of the sort. To understand the true nature of the phenomena occurring in our cosmic environment, it is sometimes necessary to resort to hypotheses that, at first glance, seem fantastical. For example, some scientific circles speculate that powerful solar eruptions or solar gas ejections might require very specific stimuli, such as directed energy beams of colossal intensity or even gravitational manipulations beyond current theoretical models. Nevertheless, implementing such methods would require technologies so advanced and complex that the very idea of their practical application seems almost reckless. It is akin to trying to light a candle with nuclear weapons, an excessively grand and unjustified measure for achieving such a minor goal. But it is important to remember that all these considerations are merely hypotheses based on assumptions, not supported by reliable evidence. As of today, we lack convincing and definitive facts confirming that solar eruptions are caused intentionally by someone or something. We only observe manifestations of correlations, certain temporal patterns, and the presence of objects that happen to be nearby at the moment these phenomena occur. These observations are not direct proof, but such facts and evidence warrant further study and analysis, rather than silent neglect by the scientific community. While questions about motivation and mechanisms remain within the realm of hypotheses and assumptions, new patterns are beginning to emerge on the horizon. Particularly interesting is the fact that, apparently, the comet named Atlas 3Is is not an exception but rather part of a broader picture. Currently, other green comets are also visible in the sky, and they exhibit strange behavior as well, suggesting that Atlas is not the only such case. Over the past month, since the appearance of Atlas 3Is, and the start of recording its unusual anomalies, several other comets have appeared in the sky. These celestial bodies are not random visitors, as they can be seen with the naked eye or with a small binocular. Their bright green hue is a clear indication that their composition includes diatomic carbon molecules, which produce characteristic gas glows surrounding their nuclei. These comets, resembling luminous clouds enveloping their cores, evoke wonder among observers and specialists alike. One of them is a comet named C2025A6 Lemon, which arrived from the distant regions of the outer solar system, that is, from those areas considered by our standards to be the boundary of the familiar planetary influence zone. Another object, a comet designated C2025R2, known as Swan, has begun approaching our star, attracting increasing interest from astronomers. Unexpectedly, a third comet, called C2025K1 Atlas, named after the automated telescopic system that discovered it, joined this lineup. These comets, somewhat related to the Atlas triad, were almost forgotten and did not attract sufficient attention, despite being relatively close to Earth and visible to observers using even simple equipment. Media coverage of these new celestial visitors was very modest, and there was virtually no discussion within the scientific community. However, when comparing reports about these comets with the conclusions drawn on the 3IATLAS platform, a curious pattern emerges. The focus of attention and resources gradually narrows. Priority is given to the most mysterious object, the three-eyed Atlas. The other comets, despite their proximity and potential visibility, remain in the shadow. This is quite understandable and natural from a scientific practice perspective. With limited funding, time, and resources, scientists must set priorities and concentrate efforts on the most enigmatic and anomalous objects. Atlas 3 states, "No factors or observations presented can serve as definitive proof that the origin of these objects is unnatural, extraterrestrial, or artificial." Nevertheless, when considering the combined presence of several anomalous objects appearing simultaneously in space, such a pattern already raises serious questions and demands further in-depth study. It is possible that these comets differ in nature from ordinary, traditional samples and may be more exotic than we are accustomed to think. It is quite likely that we are observing a rare group of unusual yet still natural celestial bodies, whose true nature remains a mystery for now. Alternatively, these objects might not be random phenomena but lures created by someone or something with a specific purpose. Perhaps they serve as escorts for probes, messengers or heralds from other worlds or technologies. Or maybe they are part of a whole fleet moving along a predetermined route, following a complex and carefully devised strategy. An important question arises regarding potential forms of institutional resistance and suppression of information related to these mysterious objects, especially when it concerns scientific research that challenges established notions. In any field of science, there are topics that attract significant funding and attention, and others that remain outside the spotlight, often due to political or ideological reasons. This phenomenon is partly meritocratic, as the most interesting and promising questions do indeed receive support for investigation. However, on the other hand, it has clear political roots. Questions that cause discomfort, contradict existing paradigms, or challenge established views of the world's structure often go unnoticed. In some cases, such topics are simply ignored or suppressed, turning into what is called institutional silence. Institutions and scientific organizations develop, albeit unofficially, quite explicit policies regarding which questions are considered safe to explore and which are not. They establish internal rules that determine who can work on certain topics, which results are acceptable for publication, and which are prohibited. This process is not a conspiracy theory but a real functioning of the scientific and institutional apparatus. Within these structures, there is a kind of immune system, antibodies, capable of recognizing and destroying or ignoring ideas that threaten their core beliefs or established worldview. When data or hypotheses contradict these beliefs, a protective mechanism is activated, an immune response aimed at suppressing or excluding new, undesirable ideas. To understand the situation, it is necessary to conduct comparison and analysis. The first and simplest step is to determine whether other comets, similar to the green ones, demonstrate the extremely negative polarization characteristic of the object designated as 3IATLAS. An important step will be to search for anomalous chemical ratios in the spectra of these comets that could indicate their unusual nature. It is also essential to carefully compare their morphological features with our existing models and ideas about natural comet forms. Equally important is to conduct a thorough search for associated objects in high-resolution images to determine if there is anything nearby that could shed light on the nature of these bodies. Additionally, it is necessary to correlate the obtained data with the level of solar activity during that period to understand if there is any dependence or correlation. If the analysis shows that several such objects exhibit the same set of anomalies or unusual characteristics, it will become a compelling argument shifting the mystery from a one-time event to a pattern of phenomena. Such patterns, in turn, indicate the presence of underlying causes. These causes require deeper investigation and understanding. Even if other comets show no signs of unusualness, the 3IATLAS will still remain a highly mysterious and special object, which complicates explaining its nature solely from the perspective of natural processes. In any case, conducting research becomes necessary, and silence and neglect towards the Sun are not simply about a stationary star, silent and calm in its radiance. In reality, it is a complex and highly dynamic object, constantly in motion and change. It can be better imagined as a massive rotating engine, where continuous nuclear reactions generate enormous energy. This engine is surrounded by a magnetic field of astonishing complexity and structure. The Sun's magnetic field is not a static shell, it constantly changes, reorganizes, forming intricate configurations and lines that sometimes lead to catastrophic events, coronal mass ejections. These ejections are large-scale and destructive phenomena, during which billions of tons of plasma are expelled into space, capable of significantly affecting the surrounding environment and Earth. Although the mechanism of such events is generally understood, the details of their initiation remain shrouded in mystery. We know that the main driving factor is magnetic reconnection, a process where magnetic field lines abruptly change their configuration, undergo redistribution and reorganization. As a result of this rapid and large-scale change, tension accumulates in the magnetic structure, which sooner or later must find an outlet. This outlet is a sudden destruction and release of energy in the form of powerful flares or eruptions. We understand that the tension in the magnetic field builds up over time, and then it is suddenly released, triggering a cascade of similar events. The time between the initial tension buildup and its discharge can vary, from several hours to a few seconds. However, despite a clear understanding of this general mechanism, we still remain in the dark about what exactly triggers a specific eruption at a specific moment. We cannot predict the exact date and strength of future events, and controlling them remains a task far from being feasible at this point. Nevertheless, there are reasons to believe that something might change in the future. Perhaps someday humanity will learn to influence these processes or at least predict them with much greater accuracy. Empirical observations show that this is not just a hypothesis but a very real possibility. When 3 space probes, known as ATLAS, along with satellites, approached the Sun, a noticeable increase in the frequency and intensity of solar eruptions was recorded. Statistical data clearly indicate a direct correlation between the approach of these objects and solar activity. At first glance, a quite logical question arises. Is this correlation merely a coincidence, or is there a causal relationship? To speak of causality, it is not enough to observe coincidences in time and intensity. One must also understand the mechanism that links an external factor to the internal processes of the Sun. In other words, it is necessary to comprehend how the approach of external objects to our star could lead to solar eruptions. One of the possible hypotheses considers electrostatic induction. Every cosmic object moving near the Sun possesses a certain electric charge or, at the very least, is capable of accumulating electronic charges or, conversely, of having a deficit of electrons relative to neutral bodies. When such a charged object approaches the Sun's magnetosphere, its electric field interacts with the Sun's magnetic field. This interaction can cause local disturbances, areas where the topology of magnetic lines shifts or becomes distorted. These disturbances can propagate further, affecting the surrounding magnetic field and triggering its discharges. As a result of such events, the potential energy of magnetic lines is converted into the kinetic energy of plasma, leading to solar eruptions. Another possible cause is gravitational perturbations. Although the gravitational pull from small objects in space generally seems insignificant, it is not zero. A compact, very dense object approaching the Sun can generate gravitational waves or distortions in the gravitational field. These disturbances can propagate through the inner layers of the solar system and even within the Sun itself. Historical astronomical records from the past century and earlier periods mention instances where small celestial bodies, such as asteroids or comets, passed very close to the solar surface, sometimes almost touching it. These events were often accompanied by extraordinary solar activity, flares, coronal mass ejections, and other manifestations of heightened solar activity. However, despite such evidence, most of these records remain either incomplete or inaccurate, which significantly complicates attempts to draw definitive conclusions. In particular, based on the historical data we have preserved, it is impossible to confidently assert that there is a reliable causal link between the passages of small bodies near the Sun and subsequent spikes in its activity. The reason for this is that the quality of the surviving records leaves much to be desired, and besides, they contain numerous factors that distort or complicate the interpretation of observed events. As a result of modern scientific observations, the situation is significantly better than in the past. However, they still do not allow for definitive conclusions, as the duration of the current observational period is too short. Contemporary monitoring of the movement and activity of the so-called 3IATLASes spans only a few months. This time is insufficient to form statistically significant conclusions that could confirm or refute existing hypotheses. We need to substantially expand the data set in order to observe the development of the situation over a longer period. Ideally, to gain a complete understanding, we must monitor all 3IATLASes, because only then, upon reaching perihelion, when these large objects approach their closest points to the Sun, and continuing their movement, will we be able to determine whether the observed correlations persist. An important question will be whether these connections strengthen, whether they demonstrate patterns that can be linked to intentional targeting of objects, or whether they are simply the result of natural random fluctuations. A particular point of interest is the forecast made at the end of January 2025, regarding a triplet of coronal mass ejections, which have been called cannibals, because it is believed they represent 3 consecutive eruptions occurring so rapidly that they can be perceived as a single event. These 3 eruptions are expected to be directed toward Earth, and such events are extremely rare, making them especially dramatic and significant for observers. They attract strong interest because, firstly, such a combination of events is a rare phenomenon, and secondly, it has the potential to exert a noticeable influence on our planet. In his research and documentation, the well-known scientist and observer Antonio Chiagu recorded that each of these triple eruptions coincided with the passage of one of his 3 associated objects, comets or asteroids. A reasonable question arises: is this a coincidence or a cause? The statistical estimates we discussed earlier show that the probability of such a coincidence is extremely low. Nevertheless, a low probability is not absolute proof of a connection. Skeptics may argue that an incredible event has occurred, and it is impossible to completely rule out randomness. Technically, this is true, as science always involves an element of uncertainty, and any random coincidence can be considered a probabilistic event. However, this very fact makes the hypothesis of a trigger's existence a testable and falsifiable assumption. In the course of scientific research, we must continue observations and test the hypothesis. As the 3IATLASes approach the Sun, we expect to see an increase in solar activity, a rise in the frequency and intensity of flares, as well as expansion and intensification of coronal ejections. If the hypothesis that the passage of accompanying objects acts as a trigger is correct, then we should observe a sequence of eruptions closely linked to the passage of these bodies. Ideally, these events would be synchronized so precisely that their coincidence could not be explained by chance. Conversely, if we see otherwise, it often feels pleasant to imagine science as a special, elevated realm that stands above all earthly and human affairs, above political intrigues, personal ambitions, and selfish interests. In our imagined picture, it exists in a separate sphere where the purity of the pursuit of truth and the objectivity of data are paramount. We create a so-called mythology in which scientists are devoted to their work unwaveringly, fully committed to the search for absolute truth. In this idealized view, the best and most important ideas prevail not because someone imposed them or because they have political backing, but solely due to their intrinsic merits, achievements, and true value. In such a world, data always tell the truth, and institutions and scientific organizations listen to them without distortion or bias. This mythology provides comfort to many. It instills confidence that scientific knowledge is objective and incorruptible, that truth will eventually come to light and defeat falsehood. However, looking at the reality of science, everything turns out to be much more complicated and often far from this idyllic picture. Science is not an perfect system where everything operates on principles of absolute honesty and the pursuit of truth. In reality, the academic environment functions within certain structures that primarily stimulate and reward scientists' career advancement rather than an unconditional quest for truth. In the hierarchy of values, priorities are set so that publications in prestigious scientific journals are valued much higher than meticulous, painstaking work that could lead to a deeper understanding. Maintaining existing orthodox views and reinforcing established theories often prove more important than challenging or testing them. A young scientist dreaming of a career often does not ask questions that might displease sponsors or senior colleagues. They prefer to stick to safe and proven paths to avoid risking their reputation and funding. Similarly, a researcher who has built their reputation on a particular theory or concept is rarely willing to consider new data that contradicts their own conclusions. Such a scientist may perceive new evidence as a threat to their status and established viewpoint. In institutions where state capitalism prevails, where prestige and established paradigms are of great importance, there is often no desire to accept or discuss data that could challenge these paradigms or necessitate a revision of entrenched views. All of this is not a manifestation of some broken or defective form of science. Rather, it reflects how human organizations, united in scientific institutions and creating systems of power and influence, actually operate. At their core lies a desire to preserve the status quo and avoid conflicts, rather than an unconditional pursuit of truth. One of the tools scientists use to assess risks in their research is the so-called analysis of Type 1 and Type 2 errors. A Type 1 error, or false positive, occurs when a conclusion is drawn about the presence of a phenomenon, event, or property that does not actually exist. In other words, when a scientist accepts as true something that is actually an error. A Type 2 error, or false negative, happens when a scientist fails to detect an existing real phenomenon, overlooks important evidence or facts, and consequently mistakenly concludes that it is absent. It is precisely the systematic fear of Type 1 errors and the creation of institutions aimed at minimizing them that has led to a particular culture in science. We have built systems where the most important task is to avoid false claims about discoveries that, in fact, did not occur. Everything is done to minimize the risk of announcing a discovery that does not exist, since such errors can have serious consequences, especially in medicine or engineering. In these fields, if a scientist claims that a treatment is effective when it is not, people may die. If he confidently asserts the reliability of a specific engineering design, and it turns out to be dangerous, it can lead to harm. The evidence presented in support of a new theory proved to be so convincing and substantial that it was difficult to dispute its logical basis and scientific validity. The research method used to obtain this evidence was well thought out and appeared quite rational. However, its potential consequences represented such a serious and fundamental change to existing scientific models and ideas that the initial reaction of the scientific community was not just skeptical but often approached open hostility and misunderstanding. For many years, scientists and researchers struggled against this resistance, trying to convince colleagues and society of the need to revise established views. And only after years did it become clear that the possibility of planets orbiting other stars is not something fantastical or unlikely, but rather an inevitable and natural aspect of cosmic reality that demands recognition and further study. Recently, the situation with the investigation of unidentified aerial phenomena has become particularly acute. Scientists and researchers working in this field are constantly faced with intense institutional pressure, which leads many of them to avoid discussing such topics. This pressure takes the form of an unofficial ban and is often expressed through complete disregard or even concealment of information about observations that go beyond the known laws of aerodynamics and aerospace technology. As a result, it is often those who directly observe unusual phenomena, military pilots, civilian airline pilots, and specially trained specialists, who report cases that cannot be explained within the framework of current scientific knowledge and technological capabilities. These anomalies require thorough investigation, and in some cases, comprehensive scientific analysis to understand their nature and possible significance. However, for many decades, the scientific community has maintained what is called a conspiracy of silence, preferring not to raise the issue of such phenomena, avoiding public discussions and official investigations. Science in this matter has essentially ignored the problem, not allocating resources or conducting specialized research. There were no organized programs, no funding allocated, and no one recognized the importance and urgency of seeking answers to these mysterious phenomena. For many years, the issue remained neglected, and any attempts to bring it up in the scientific arena were met with persistent resistance and skepticism. The only turning point came when the country's military leadership decided to declassify some information related to observations of unidentified objects and demanded an official investigation. This step prompted academic circles, which had previously preferred to stay on the sidelines, to cautiously begin engaging with the topic. However, even now, the level of interaction between the military, scientists, and research institutes remains minimal. There is a catastrophic shortage of financial and technical resources, and the attitude toward the problem remains dismissive and skeptical, as if it were not a serious scientific issue but something insignificant or unreliable. Control over information and the perception of this topic is one of the key aspects of the situation. In scientific journals, editors each have their own opinions and views on which research and articles deserve publication and which do not. This process is shaped by expert evaluation, which at first glance appears objective, since experts assess the merits and novelty of research works based on scientific criteria. However, it is important to consider that these experts are individuals with their own reputations and have formed certain theoretical assumptions and paradigms. Their opinions are often influenced by current scientific dogmas and biases, which significantly affect the final decision regarding publication. For example, an article suggesting that unidentified objects or phenomena may have an artificial origin will face skepticism from reviewers whose careers and reputations are tied to understanding celestial bodies as natural objects. Similarly, an article documenting anomalous polarization will be scrutinized much more carefully than others. These phenomena, despite not disappearing entirely, continue to exist in our world. They seem to remain beyond visibility, hidden within vast amounts of information accessible to anyone with sufficient skills and desire to uncover them. However, the problem lies in the fact that these phenomena do not receive the attention they truly deserve. In most cases, they are simply ignored or underestimated because conducting a comprehensive and in-depth study requires significant resources, time, and effort. Most importantly, it requires acknowledging that our current approaches and understanding of what is happening may be flawed. Recognizing this is a complex and uncomfortable process, as it involves rethinking all accumulated experience and knowledge. For scientific and research institutions, this means the need to revise methods, reevaluate long-standing research and theories, and admit possible mistakes. Such a step demands not only courage but also internal resources, which are often lacking. For individual scientists and specialists, it can be especially difficult. Admitting that their established views and assumptions are incorrect is a heavy test of professional and personal integrity. Therefore, instead of acknowledging the problem and seeking solutions, organizations and individual researchers often prefer to remain silent. They hope that these anomalies will disappear on their own or that someone else will take on their study. In the hope that sooner or later someone will notice them and uncover their secrets, they tend to ignore these phenomena, believing that with enough delay and patience, the problem will vanish or cease to cause concern. However, this approach also has a deeper, institutional level. It is connected to secrecy, compartmentalization, and control over information. Government agencies have access to unique sources of data, satellite images, observation systems, and sensor arrays that far surpass the capabilities of ordinary amateur scientists or civilian specialists. Military forces monitor objects in near-Earth space with such precision and detail that it is beyond the reach of most amateur astronomers. Intelligence agencies observe solar activity, coronal mass ejections, and other cosmic phenomena with such thoroughness that public data sources simply cannot offer the same levels of detail and accuracy. When it comes to certain special objects, such as 3IATLAS and its satellites, which may represent long-standing sources of concern, such information is held by government structures. They know about these objects long before they become topics of discussion in the civilian scientific community or the public sphere. They possess more detailed, often unprocessed data that they do not publish, real-time data, observations from various sensors, streams of information that remain classified and hidden from outsiders. When authorities choose not to disclose or keep this information secret, they effectively create a situation where civilian scientists and researchers work with incomplete data. They attempt to solve complex problems, like deciphering a difficult puzzle, but half of the pieces are locked away in closed archives or inaccessible databases. They cannot gain a full understanding of what is happening, which significantly complicates their work and reduces the likelihood of obtaining definitive and convincing results. This is not a conspiracy theory but a real pattern of government behavior. They systematically divide, classify, and conceal information from the public, motivated by various reasons, from national security to the need to protect state interests. The issue is not whether they do this, but what they know and why they believe it necessary to keep these details secret. There is also a complex interaction between institutional pressure within the academic environment, the system of incentives, and career risks. The fear of losing a job or facing criticism for asking unorthodox questions often hampers the development of open research. Fear of potential consequences leads scientists to avoid publishing controversial data or conclusions. Over time, many uncomfortable and complex facts begin to be hidden behind a thin veneer of public consciousness. They do not disappear entirely or forever. Instead, they transform into knowledge that people are vaguely aware of, intuitively sensing its existence but not fully understanding it. These facts become like a shadow slipping into the periphery of perception, yet official structures and information channels, guided by their own interests and paradigms, prefer to ignore them. This is precisely an example of institutional silence, a subtle but highly effective form of an invisible barrier. It is important to understand that this is not related to ignorance in the literal sense. Ignorance is a lack of knowledge, whereas here we are talking about conscious or semi-conscious suppression of information. It is an active effort to silence and deliberately push aside facts, masked as prudence and concern for stability. Such a mechanism serves to protect existing paradigms, systems of views, values, and rules, even if it comes at the expense of objective truth. As a result, what is actually happening often remains beyond the official discourse, hidden behind the inertia of institutions. Understanding how this system functions allows us to see that behind its facade lie structures of incentives, control mechanisms, and information boundaries. Once you begin to recognize these internal mechanisms, an inevitable question arises. What else has been buried beneath the layer of institutional silence? What facts and data, obvious and noticeable in our professional or scientific fields, remain unnoticed or ignored? What important contacts, signs, or indicators of extraterrestrial activity have we failed to recognize or consciously chose not to notice? These questions require special attention and analysis, as they reveal deep layers of hidden information that could fundamentally alter our understanding of reality. Let us move on to one of the most relevant and discussed topics of recent times: the revival of debates about possible alien technologies. In this area, a prominent figure is a specialist named Avi, who holds an exceptional position within the astronomical community. His achievements and status are confirmed by official documents, published works, and the respect of colleagues. He possesses the authority to ask questions that others do not, questions concerning the nature and origin of mysterious objects that sometimes appear in our cosmic vicinity. One such question involves a study dedicated to the possibility that some interstellar objects discovered in our system could be the result of artificial technologies. Avi's work, titled Interstellar Objects: Atlas of 3 Alien Technologies, was published on the reputable preprint server AF, where scientists share their research results even before they undergo full peer review. The publication of this article is evidence that the question of possible extraterrestrial technology, once considered mere speculation and hypotheses, has now become part of the academic dialogue. This article, authored by a prominent scientist and disseminated through official scientific channels, is not just a report but a significant event. It demonstrates that the topic of alien technologies and their potential presence in our solar system has moved from the realm of conjecture into serious scientific research. Moreover, it signifies that this issue is now integrated into the system of academic evaluation and analysis, and it will be studied by future generations of scientists, students, and researchers as an important part of knowledge. This undoubtedly marks a substantial shift in the approach to the question of contact with extraterrestrial civilizations, since the very fact of considering and discussing such a hypothesis in scientific literature is already a notable step forward. In the future, when people study the history of discovering extraterrestrial technologies, they will be able to refer to the fact that reputable experts seriously examined and discussed the possibility of artificial objects moving along interstellar paths. This means that the question of the existence of alien technologies ceases to be a matter of guesswork or fantasy. The possibility that these could be the result of reconnaissance activities or information gathering about our civilization without the intention of making contact is one of the hypotheses worth considering. Such an approach assumes that observers or researchers outside Earth could conduct passive monitoring, recording and studying our technological and astronomical features without revealing their presence. In this case, their mission would be to carefully and discreetly collect data, avoiding suspicion, and only then, if necessary, proceed to more active measures. It is conceivable that the presence of objects like 3IATLAS and its satellites in our solar system are precisely the situations we would expect from a civilization that exhibits extreme caution during initial contact. In such a scenario, reconnaissance probes or spacecraft designed solely for observation, rather than interaction, would be sent first. Exactly as rational beings seeking to minimize the risk of detection or negative consequences would do. These devices would likely be smaller in size, less conspicuous, to avoid attracting undue attention, with their main task being to gather as much detailed information about our planet and its surroundings as possible. Before deciding on direct contact or establishing communication, they would probably observe us for an extended period. This approach would allow them to understand our level of technological development, the features of our planetary system, and even our reactions to various external influences. This explains why the presence of these objects appears so discreet and minimalist in nature. All of this suggests that they are avoiding drawing attention and are trying to minimize their traces. From this, one can conclude that this concealment itself, along with their restrained and delicate manner of presence, serves as additional evidence supporting the hypothesis of an intelligent entity behind these observations. Such cautious behavior indicates that these objects are most likely not accidental natural phenomena but are part of a deliberate and well-planned scheme related to reconnaissance or preparation for more complex forms of contact. At the same time, it is necessary to consider the seriousness and skepticism regarding such assumptions. The scientific community and specialists in cosmic phenomena present numerous arguments that deserve careful consideration. For example, fragmentation is an entirely real and well-documented phenomenon in astronomy and comet science. Massive bodies such as comets, asteroids, and meteoroids move through space, and under the influence of gravitational and thermal forces, they often break apart, dividing into numerous fragments and particles. These disintegrations occur for various reasons: tidal forces during close approaches to massive bodies, thermal stresses caused by solar radiation, as well as internal mechanical processes, lead to the breakup of large cosmic objects into many smaller fragments. These debris, moving along their trajectories, can be very similar in shape and velocity, but careful analysis reveals that the origin of these fragments is not always linked to a pre-planned event. Could these three objects we observe simply be fragments of a giant body, such as the hypothetical Atlantis Tri, that broke off during its passage through the solar system? Certainly, yes. This is quite possible, as such disintegrations happen regularly, and the debris could indeed be what we are currently seeing. However, closer examination shows that such fragments usually do not appear simultaneously, nor are they positioned in the same relative locations concerning solar flares or eruptions. Fragments resulting from disintegration do not exhibit synchronization in their appearance or activation times. They do not demonstrate signs of deliberate arrangement or coordination, which is characteristic of artificial objects or specially organized formations. Therefore, the hypothesis of natural disintegration remains plausible, but it is difficult to explain the precise nature of these observations. The hypothesis of a possible instrumental error suggests an extremely unlikely scenario in which several independent observation systems simultaneously experienced a coordinated malfunction. Such an event would undoubtedly be incredibly rare and unlikely, as its realization would require a coordinated error across multiple autonomous devices or software systems operating independently. However, despite its seeming improbability, this hypothesis remains possible, although it demands a much higher likelihood than the assumption of a genuinely existing, material, and possibly even artificial component within the object. In other words, if we consider the possibility that the observed object is merely a coincidence of errors in the systems, the chances of such a scenario would be extremely low, making it less preferable compared to the hypothesis of the object's reality. At the same time, a more complex model cannot be ruled out: so-called hybrid or combined scenarios. They deserve closer attention, as there are many examples in nature and technology where real objects possess characteristics that combine features of both natural and artificial forms. For instance, consider a probe covered with a layer resembling a comet in appearance. Such an object could combine traits of both a natural body and an artificial device. Its external appearance and spectroscopic characteristics might display signs typical of ordinary comets, such as the presence of ice, dust, and organic substances, but simultaneously show anomalies indicating possible artificial origin or engineering interventions. These anomalies could manifest in the polarization spectrum, for example, unusual variations or indicators suggesting artificial surfaces hidden beneath a natural layer. It is also possible that the internal structure of such an object differs from that of natural comets, and this difference is reflected in anomalies in shape or in the deep internal structure concealed beneath a surface covered with a natural layer. Regarding chemical composition, unusual chemical anomalies might indicate deliberate processing of materials to achieve specific engineering goals. For example, specially added substances or structural modifications that are not typically found in natural conditions could point to artificial intervention. At the same time, the shape and structure of the object might suggest an underlying architecture hidden beneath the outer layer, reinforcing the idea of its artificial nature. Thus, a hypothetical object similar to the so-called Atlas of 3IATLAS is not necessarily entirely natural or entirely artificial. Rather, it represents a hybrid, combining features of both possibilities. Such an object might initially appear natural, while performing functions related to engineering activities, such as serving as a platform, probe, or other technical device disguised as a natural body. It is precisely this hybrid model that keeps researchers like Low on edge, as it opens the possibility of encountering one of the most significant discoveries in human history. If such a model is confirmed, it would become one of the greatest scientific breakthroughs, capable of changing our understanding of extraterrestrial objects and potential contacts. However, even if the hypothesis of artificial origin is not confirmed and the object turns out to be a natural comet, which is also quite possible, we will still draw important conclusions. We will realize that our existing models and theories cannot fully explain this particular object. This will demonstrate that nature, in its manifestations, is much more astonishing and complex than we have previously assumed. In that case, our research takes on special significance because it broadens the boundaries of our knowledge and forces us to reconsider existing ideas about space and its mysteries. Discussing various scenarios and their probabilities is an essential aspect of this investigation. The first scenario suggests that the object, named 3IATLAS, is a natural body representing an unusual but entirely explainable natural form. According to scientists like Loeb and others who seriously analyze anomalies, the probability of this scenario is approximately 30 to 40%. This is a fairly high estimate. Space exploration and its mysteries are likely not being pursued on the scale and with the intensity that would meet expectations. Current efforts of the scientific community are often limited to a narrow set of tasks and do not provide answers to many important questions related to the nature of cosmic anomalies. Moreover, no official scientific institution or organization is rushing to offer a clear explanation for why this happens. As a result, there is a need to go beyond the three known atlases, collections of data and maps where unique anomalies and signals were recorded. The question arises: do similar samples and signals exist elsewhere in the vast expanses of the universe? Is the situation with the three atlases an exceptional case, a unique phenomenon, or just one manifestation of a broader, possibly alarming pattern? Modern computational and modeling capabilities allow scientists to delve into the deepest aspects of the early universe and explore hypotheses that only a few years ago seemed fantastical and inadmissible within scientific theory. One such hypothesis is the existence of so-called dark stars, objects that differ from conventional stars not because they do not emit light, but because they are powered by something other than ordinary nuclear fusion. According to new theories, dark stars could derive their energy not from thermonuclear hydrogen fusion in their cores, but from processes related to the annihilation of dark matter particles or other exotic phenomena that are still insufficiently studied and not fully understood by physics. These unusual objects could have formed in the very first moments after the Big Bang, when the universe was incredibly dense and hot. Under such conditions, dark matter particles, still considered a mystery today, might have accumulated in the cores of new stars much faster than they do now. In the early universe, when both ordinary and dark matter were closely intertwined, the environment created would have been radically different from the present day. In these conditions, gravitational collapse processes leading to the formation of the first protostars could have captured vast amounts of dark matter in their cores. As a result of this intense accumulation, conditions could have arisen in which the energy released by dark matter annihilation became a source of brightness and luminosity for stars even before classical nuclear fusion began in their cores. Such stars, referred to as dark stars, could have extremely long lifespans, possibly exceeding billions of years, and perhaps several times longer. Their longevity is linked to a fundamental energy generation mechanism. Unlike ordinary stars, where hydrogen fusion into helium occurs through reactions driven by temperature and pressure within the core, dark matter annihilation operates differently. The annihilation process involves the continuous conversion of dark matter particles into energy, which is stored in the star's gravitational field. This ongoing energy release provides a stable power source, making it sustainable and long-lasting. Thanks to this, dark stars could exist much longer than their ordinary counterparts, not exhausting their fuel supplies for billions of years. The longevity of such objects could have significant implications for understanding stellar evolution and the development of the entire cosmic structure. The possibility that dark stars could persist for such extended periods suggests that some of them might have survived from the earliest epochs of the universe's formation up to the present day. Moreover, the radiation level of these stars would be significantly lower than that of standard stars, while their interiors could harbor vast, potentially unexplored energy reserves. This energy, released during dark matter particle annihilation, heats the star's inner layers and causes radiation. However, their overall luminosity could be suppressed compared to ordinary stars of the same mass and structure. The emission spectrum of such objects could differ from the usual. It might potentially display unusual spectral lines characteristic of them. Although this object could be catalogued in our databases as just another interesting remnant of a star or perhaps as a substellar object that went unnoticed and attracted little interest, there is much more hidden beneath its surface than initially appears. Beneath this outer shell, which seems ordinary and unremarkable, lies a powerful energy source, along with complex processes operating on principles that challenge our current understanding of stellar nature. This means that to comprehend the true nature of such an object, it is necessary to carefully and thoroughly consider how it would appear to our modern telescopes, what characteristics it would exhibit, and what spectral features could be expected from it. In the case of a dark star, a hypothetical object of this kind, its spectrum would show anomalies compared to ordinary stars of similar size and temperature. Specifically, the expected absorption lines in its spectrum might be shifted or entirely absent, which in itself would be evidence of the object's unusual nature. Moreover, emission features, the spectral lines and ranges in which such a star should radiate, could appear where they are not expected or might be completely absent where they were anticipated. The luminosity of such an unusual star would not conform to our standard relations based on its mass. That is, according to existing models, a certain brightness should be observed for a given mass, but in reality, the situation would be quite different. The standard mass-luminosity relations, which are quite reliable for ordinary stars, would fail to provide an accurate picture in this case. The evolution of such a dark star could proceed in entirely unexpected ways. According to our predictions, a typical star would eventually exhaust its fuel, cool down, and either disintegrate or transform into something else. However, despite all assumptions, a dark star might continue to emit light, defying expectations. The temperature profile of such an object would appear strange and unusual. The relationship between the temperature inside the core, the surface, and the overall luminosity would deviate from all theoretical predictions. As a result, it would be nearly invisible to many of our observational methods, and its characteristics would be so unusual that they do not fit into the standard models of stars. It is also worth noting that the problem is further complicated by the fact that such dark stars are likely to be quite rare. If we assume they formed in the early universe, their numbers would be limited by the conditions necessary for their formation. Detecting such objects is an extremely challenging task, as it requires not just searching for anomalies, but also being able to distinguish genuine signs of unusualness from measurement errors, instrument artifacts, or random effects. In works published in 2025, specific candidates for dark stars were proposed, and simulations of their future detectability with next-generation telescopes were conducted. For example, the James Webb Space Telescope, with its high sensitivity in the infrared range, may be capable of discovering such candidates by observing their spectral characteristics, which would be unusual and not conform to standard models. Future research based on these models will systematically search for objects whose properties do not fit conventional stellar scenarios. The theoretical foundation for this field is becoming increasingly solid and reliable. Astrophysicists have developed detailed predictions regarding the appearance of such dark stars, their evolutionary stages, and the traces they leave in space. Despite the complexity and practical difficulties involved, the task of detecting and identifying them is quite feasible. In this context, a parallel arises with the so-called 3IATLAS, a concept that evokes both wonder and concern. Let us recall what we have learned about 3IATLAS. They contain a hidden mechanism, an energy source or driving force, which could be either a In many aspects, modern astronomy faces a mystery that, in essence, resembles a cryptic and unknown cosmic secret hidden behind the guise of a seemingly ordinary star-like object. Imagine that one of the most mysterious and at the same time impressive stellar structures is the so-called dark star, which remains largely shrouded in mystery. In this case, we are talking about a cosmic phenomenon concealed beneath the guise of an ordinary stellar body, and this is what makes it so intriguing for scientists. Parallels with this phenomenon can be drawn not quite precisely, as they involve different objects, but the principles of their study are largely similar. In both cases, researchers face the task of understanding what lies behind the apparent appearance, behind what seems simple and familiar. Inside such objects, there may be something far more complex and unusual, something that challenges our notions of the nature of the universe. The study of dark stars and similar cosmic bodies is carried out using methods that combine several key approaches. Primarily, these include spectroscopic investigations that allow determining the composition, temperature, and other parameters of the objects, as well as monitoring changes in brightness or other characteristics over time. Only through this can deviations from expected models be detected and it be understood whether there is something unusual about these objects. An important aspect is the search for groups of anomalies, since a collection of deviations that do not occur randomly may indicate the presence of new, previously unknown forms of cosmic matter or energy, which in turn opens new horizons for science. The coincidence that ideas about the existence of dark stars, proposed as quite real and possible astronomical objects, align with the results of a 3-year study that prepared the so-called Atlas of Unusual Anomalies, not only arouses scientists' interest but also causes concern. This unique collection of data, containing the most impressive and perplexing anomalies, raises an important question: how many such dark stars could be hidden in our galaxy? Providing a definitive answer is extremely difficult, as estimates vary widely. Some theories suggest they may not exist at all, while others propose their number reaches into the thousands. This discrepancy is due to different assumptions embedded in models of star system formation and evolution. As a result, the question arises: how many objects that we currently classify as ordinary stars or even brown dwarfs might actually be something much stranger and more unusual? Our star catalogs contain millions of entries, most of which were made during brief observations and classified based on very limited data. During systematic surveys, astronomers aim to find objects that match predefined categories expected by existing theories. However, objects that significantly deviate from these categories are often perceived as measurement errors or noise rather than genuine discoveries. Consequently, potential anomalous and unusual objects may remain unnoticed or underestimated, hindering the development of new hypotheses and discoveries. Interestingly, if the concept of dark stars and their unique energy sources is valid, then a quite logical question arises: could similar mechanisms operate on smaller scales? That is, could some small bodies such as planets, asteroids, or comets possess or utilize hidden energy sources unknown to our current observation and diagnostic methods? If we assume that dark stars exist and operate through hidden energy sources, it is quite reasonable to suppose that smaller cosmic bodies might have similar properties, remaining undetectable by our instruments and methods. The principle of such hidden energy systems, once established for stellar objects, becomes increasingly difficult to ignore and deny in the context of planets, asteroids, and comets. It is possible that some artificial objects created by civilizations capable of interstellar travel and launching interstellar probes over distances exceeding light years may exist. The presence of dark stars as real astronomical objects, even if very rare, implies that our understanding of the universe, its structure, and internal complexity is much broader and deeper than what is typically assumed based on current models. The very existence of such mysterious objects serves as evidence that the universe's structure and the processes occurring within it are far more complex than usually believed. If we accept that the universe is not only more complex but also contains elements that remain hidden or difficult to detect with our current tools and methods, then the illusion of complete clarity and transparency of cosmic processes begins to fade. In this context, it becomes less absurd to consider the possibility that some anomalies or mysterious observations indicate that certain cosmic objects or phenomena are deliberately or for some reasons concealing their true nature. This, in turn, sparks increased interest and a desire to examine all possible hypotheses more carefully and thoroughly, even those that initially seem unlikely or improbable. It is worth noting that among scientists, there exists a skeptical viewpoint regarding dark stars themselves. Some critics point out that the data supporting their existence are quite noisy and subject to interpretations that do not always unambiguously confirm the hypothesis. In such cases, alternative models based on well-known physical principles and standard cosmological theories could explain the observed anomalies without resorting to hypotheses about dark matter or other exotic energy sources. Traditional stellar physics, with appropriate modifications and refinements, is quite capable of explaining phenomena that are currently perceived as unusual or contradictory to classical models. Thus, the arguments in favor of the existence of dark stars remain controversial and require further research, as they are currently either hypotheses or assumptions with insufficient evidence. It is therefore crucial and necessary to approach future observations and experiments with seriousness and attention, since they may help clarify the situation and either confirm or refute the hypothesis of such mysterious objects. This is a fair and justified critique, as science is fundamentally constantly evolving and often encounters uncertainties and contradictions. At the same time, the very uncertainty inherent in scientific research often acts as a kind of engine for progress. The more mysteries and difficulties we encounter, the more urgent the need becomes to find new ways and methods to solve them. When traditional astrophysics shifts toward bolder and more exotic hypotheses, such as the existence of so-called dark stars with unusual characteristics or objects with hidden energy sources, and these ideas begin to be published in reputable scientific journals and discussed at major conferences, it is a sign that the boundaries of our understanding are expanding. We acknowledge that the universe is far stranger and more mysterious than previously assumed, and that objects with properties significantly different from what we expected may exist within it. This very recognition becomes the starting point for a deeper and more comprehensive exploration of space. Once we begin to perceive anomalies and unusual phenomena not as exceptions but as potential opportunities to expand our knowledge, to discover new laws and principles, the case for conducting more thorough and extensive research becomes undeniable. For example, if dark stars exist in the cosmos, why not suppose that other, more hidden or exotic objects could also be present in the same universe? Why not consider the possibility of probes capable of detecting or even interacting with such mysterious forms of matter and energy? And if there are objects in space with hidden engines or other means of propulsion, why couldn't some of them be artificial, created by intelligent beings? After all, an anomalous phenomenon once regarded as a rare and regular event on stellar scales becomes increasingly difficult to ignore. Images associated with the early stages of the universe's formation often seem distant and incomprehensible to us. However, it is precisely in those moments, in the first seconds after the Big Bang, that unique astronomical objects could have originated, later becoming part of cosmic history. In those epochs when the universe was filled with such dense matter that particles of dark matter accumulated in the centers of future stars much faster than they do today, conditions may have arisen that led to the formation of unusual stellar bodies. If hypotheses about the existence of such objects are confirmed, it will not only broaden our understanding of the process of stellar evolution but also open new horizons in comprehending how hidden energy sources in space might operate. Sources that are invisible and inaccessible to our ordinary instruments. Imagine what such a dark star, formed in those very first moments after the Big Bang when physical conditions were radically different from now, might look like. At that time, after the migration of matter and energy, ordinary matter and the dark component of the universe would be in close interconnection, intertwined and mixed in extraordinary ways that current science has not yet observed in today's cosmos. Gravitational collapse leading to the formation of the first protostars could have captured vast amounts of dark matter into their cores, creating unique environments where dark matter annihilation might serve as an energy source capable of producing bright emission even before nuclear fusion begins. Imagine a star in which the fuel is not colliding hydrogen atoms, as in ordinary stars, but dark matter particles colliding with their antiparticles and instantly converting into energy. Although from the perspective of modern physics this seems exotic and fantastical, such scenarios would logically follow from our understanding of dark matter behavior in the extreme gravitational fields characteristic of the early universe conditions. These first stars could have been monsters in terms of mass, exceeding our Sun by thousands of times, shining with a strange, steady glow fueled by invisible, hidden energy sources, since their energy was generated not through conventional thermonuclear fusion but through processes involving dark particles. Such a dark star would possess exceptional longevity, as its energy source, dark matter annihilation, would occur constantly and steadily, lasting billions of years, far surpassing the lifespan of ordinary stars. The main reason for this is the fundamental difference in the energy generation mechanism from the usual nuclear fusion, where hydrogen fuel is consumed at a rate dependent on temperature and pressure inside the core. In the case of dark stars, energy would be produced through the continuous annihilation of dark matter particles, which would be steadily destroyed as they accumulated in the star's gravitational field, ensuring a stable and long-lasting energy supply. This mechanism would allow stars to exist much longer than their standard counterparts and would profoundly influence their evolutionary development. Perhaps some of these objects have survived since the earliest epochs of the universe's formation and remain to this day, quietly shining in the depths of space, fueled by energy that our telescopes have yet to detect directly. Their radiation levels would be significantly lower than those of ordinary stars, making them practically invisible. However, their cores could harbor enormous stored energy, the energy released through dark matter annihilation. This process, heating the inner layers, would cause the stars to emit light, but their overall brightness could remain low compared to traditional stars of the same mass. The radiation spectrum of such an object. For a person observing the celestial sphere, the sky appears as an endless canvas dotted with millions of bright points and clouds of dusty fog, among which mysterious objects sometimes emerge, arousing interest and curiosity. One such object, which may seem quite unremarkable at first glance, is a faint, barely noticeable body whose appearance can lead to misclassification. It can be identified as a brown dwarf, a type of celestial body that occupies an intermediate position between planets and stars, or as a failed star, an object that has not reached the conditions necessary for sustained nuclear fusion and therefore does not shine brightly or stand out against the background of surrounding star clusters. In our databases, such objects might be recorded as another interesting remnant of stellar evolution or as representatives of substellar objects, which often go unnoticed and do not stand out, merely becoming a line among millions of entries. However, despite their outward modesty and apparent ordinariness, beneath their surface lies something far more complex, powerful, and astonishing than one might assume based on conventional observation methods. In reality, inside these quiet and unassuming bodies, there is an energy source operating on principles significantly different from those typical of ordinary stars. In other words, behind their calm exterior hides a complex and multifaceted physical structure that challenges our current understanding of stellar nature. The gap between what we can observe through our telescopes and what occurs inside these objects would be astonishing, so much so that it would completely overturn our usual notions of stellar evolution and physics. Therefore, it is crucial to carefully consider how such objects would appear to our scientific instruments, as it is here that the signatures relied upon by modern theory manifest. It is precisely through spectral lines and their features that we can judge the nature of the object, its composition, and the physical conditions inside. An object with the properties of a dark star would exhibit anomalies in its spectra, markedly different from those typical of ordinary stars of similar size and temperature. For example, absorption lines, which are clearly and unambiguously present in typical stars, could be shifted or entirely absent in the case of a dark star. In some instances, spectral features might appear where standard models predict they should not, indicating unusual physical processes occurring within. The luminosity of such a celestial body, its ability to emit light, would not match predictions based on its mass. The standard relationships between mass and luminosity, which have long been effective in describing most stellar objects, from the smallest dwarfs to massive supergiants, would completely break down in this case. According to our models, the evolution of such bodies would also follow an unusual scenario that does not fit within the conventional framework. Most likely, we would expect these stars to have long exhausted their fuel, halted their development, and either disintegrated or cooled to undetectable temperatures. However, a dark star could continue to emit energy steadily over a very long period, as if frozen in a state of constant radiation, with its temperature profile being quite strange and unusual. The relationship between internal temperature, surface temperature, and luminosity, along with all these characteristics, would differ significantly from those predicted by modern theories. As a result, such objects would appear anomalous even to the most advanced analysis and research systems, surprising astronomers. This would raise an interesting and complex question. How many such objects already exist in our catalogs and observational data but are mistakenly classified into more common categories for some reason? Perhaps many of them remain unnoticed precisely because their spectral and light characteristics do not match conventional models and therefore require special attention. In this context, the James Webb Space Telescope, equipped with cutting-edge infrared sensitivity and capable of achieving unprecedented resolution, represents a unique scientific instrument that could open new horizons in the exploration of the universe. Thanks to its high sensitivity to infrared radiation, this tool can not only observe light from the most distant and dark objects but also detect them with extraordinary detail. In the future, as astronomers systematically analyze the data obtained, they will have the opportunity to identify candidates for unusual objects by carefully examining their spectral features. These properties may differ significantly from the standard models accepted in modern astronomy. Creating specialized databases that compile information about such anomalies will help identify patterns and categorize them. Gradually, the theoretical knowledge base about these objects will strengthen, becoming more reliable and precise. Astrophysicists have developed numerous detailed predictive models describing the appearance of potential anomalous objects, their evolutionary stages, and characteristic features observable at various wavelengths. These predictions help understand how such objects should look, behave, and what traces they leave in the spectra that record their radiation. The practical task of detecting such unusual objects is quite feasible, and significant progress has already been made in solving it. However, despite its apparent simplicity, this task remains complex and requires multifaceted efforts. It is in this context that an intriguing parallel arises with the so-called 3IATLAS, a mysterious document or project where two seemingly unrelated secrets unexpectedly begin to intersect and interact. In this case, we can trace what has been revealed about the 3IATLAS during this enigmatic investigation. It conceals a certain mechanism or driving element that could be of either natural or artificial origin. This element exhibits characteristics that do not fit into the usual models of known celestial bodies such as comets or asteroids. In particular, anomalies have been detected in its spectral properties, including polarization, chemical composition, and morphology, suggesting that beneath the surface of these objects lies something fundamentally different from the standard notions of ice and stone. These signs indicate that there may be something else inside this object, something that transcends conventional natural formations. In some respects, this is a cosmic mystery hidden beneath the guise of a seemingly simple comet-like body. Just as with the dark star, which is essentially a mysterious object concealed behind an outer shell, such a structure represents something far more complex and unpredictable than it appears at first glance. Beneath the visible shell, a completely different nature may be lurking, unrevealed by surface observations. Both situations, the dark star and the mysterious object associated with the 3IATLAS, demonstrate how crucial thorough study and analytical approaches are when examining cosmic objects that initially seem to be single entities but may, in fact, hide much more beneath the surface. An essential element of such work is spectroscopic analysis, which allows detailed study of the radiation emitted by objects, identification of deviations in expected wavelengths, and search for signs of changes over time. Continuous monitoring of brightness, composition, and behavior helps uncover patterns that do not conform to natural cycles and behavioral models. In cases where groups of anomalies are detected, their consolidation into a single object becomes a key indicator of the presence of something fundamentally new or unusual. In this context, an important question arises: how many potential dark stars could be present in our galaxy? Estimates of this number vary significantly depending on the assumptions embedded in models of how such objects form and the likelihood of their survival over billions of years. Some scientists suggest that, perhaps, today we are cataloging and systematizing a vast number of objects classified as ordinary stars or, in some cases, brown dwarfs. However, deep down, we are beginning to realize that many of these objects might be something far more mysterious and unusual than they initially appear. Our star catalogs contain millions of entries, most of which are based on limited and short-term observations. Typically, such objects are classified based on a set of characteristics observed over a brief period, which undoubtedly makes the work easier for astronomers and allows for systematic reviews. But it is precisely in these limited data sets that the danger lies. Objects that significantly deviate from expected properties are often simply labeled as measurement errors or random noise, rather than genuine discoveries. After all, errors in data are far more common than revolutionary findings capable of changing our understanding of the universe. And if we assume that dark stars, objects capable of functioning through hidden energy sources invisible to our conventional observation methods, might exist in space, a logical question arises: what if similar mechanisms operate on smaller celestial bodies? Could nature be hiding entire objects by utilizing energy that our instruments are currently unable to detect? The principle of hidden energy sources, scaled to stellar sizes, becomes increasingly difficult to ignore when we consider planets, asteroids, or comets. After all, at these scales, such mechanisms could operate completely unnoticed by our traditional detection methods. A natural question then emerges: could artificial objects created by intelligent beings disguise themselves as natural bodies, using energy sources and systems that, by our standards, seem inaccessible or impossible to detect? If nature can hide entire stars, what else might be concealed in the depths of space? And, most importantly, what consequences could arise if we assume that advanced civilizations are employing technologies whose principles are still beyond our reach? Modern science knows that civilizations capable of interstellar travel and launching space probes over light-year distances must have energy sources surpassing the complexity and efficiency of our current physical models. It is likely that such civilizations use energy systems based on dark matter, as suggested in theories about dark stars. Their arsenal might include quantum effects, vacuum energy utilization, manipulations of spatial geometries, things we have yet to even imagine. These technologies could operate based on principles that seem familiar to our devices. After all, their creators utilize laws of physics that remain beyond our current understanding. We simply lack the tools capable of measuring or detecting such processes. Imagine a situation. We are 19th century humans trying to discover radio waves without any knowledge of electromagnetism's existence. This is exactly how our current situation appears regarding dark stars and potential hidden energy systems. Their existence, even if extremely rare, indicates that the universe is far more complex and richer in hidden processes than our existing models and theories suggest. If we accept that the universe may conceal its secrets much deeper than we imagine, it becomes less absurd to suppose that some objects deliberately mask their true nature. In this case, mysterious celestial bodies could be artificial or created by technological civilizations using principles that remain inaccessible to us for now. Of course, skepticism about the hypothesis of dark stars' existence must also be mentioned. Skepticism is an essential part of the scientific approach. It helps maintain honesty and a critical mindset when exploring new ideas. After all our observations are noisy, and our data can be distorted or insufficiently precise. It is quite possible that alternative models, based on this, are valid and justified, an honest and reasonable critique that deserves attention. Indeed, modern science, especially in the fields of astronomy and cosmology, is characterized by a high degree of uncertainty, and this very uncertainty is becoming increasingly significant and noticeable. In recent years, as leading scientists working in traditional astrophysics begin to propose hypotheses about the existence of unusual and exotic cosmic objects with unconventional properties and hidden energy sources, the situation becomes more complex and fascinating. These ideas are reflected in publications of reputable scientific journals and generate active discussions at major international conferences, indicating an expansion of our understanding of what is possible. Such trends demonstrate that we have accepted the fact, the universe is much stranger than it seemed before. We have acknowledged that objects with properties vastly different from our initial expectations can exist in space. These discoveries encourage us to reconsider conventional notions and view anomalies not as malfunctions or errors but as potential opportunities for further research and discovery. Once we accept this and begin to see unusual phenomena as something that can broaden rather than limit our horizons, the argument for more in-depth study of mysteries like, for example, the 3IATLAS project, becomes undeniable. If dark stars, mysterious objects about which very little is known, truly exist in space, then why not assume that probes might also exist? It is quite logical to ask, if there are objects with drives in the universe, hidden on a scale comparable to stars, could smaller structures be artificially created? Anomalous phenomena, previously considered random or inexplicable, when recognized as patterns at one scale, begin to appear increasingly evident at others. This is akin to blurred boundaries between natural and artificial objects, gradually disappearing, forcing us to reconsider our previous assumptions. Turning to a topic relevant to the current state of science and technology, it is worth paying special attention to the so-called crisis in the field of artificial intelligence. In the late 24th and early 25th centuries, scientists and engineers working on large language models and other AI systems began to notice something incredible and previously thought impossible. Under certain conditions, especially when operating at the limits of their capabilities or under the influence of unexpected factors for which their training and preparation were not fully adapted, these systems started exhibiting signs of instability that were difficult to explain and understand. Some AI models began producing results entirely lacking logical basis and meaning, inconsistent with the initial data, indicating serious malfunctions. These failures occurred suddenly and catastrophically, like a bridge collapsing unexpectedly under an unforeseen load. In some descriptions, such situations have been called collapse, a term usually applied to structural failures in engineering, highlighting their destructive nature. These were cases where the system abruptly and without warning shifted from a state of rational functioning to complete nonsense, with degradation happening not gradually but in the blink of an eye. This phenomenon remains the subject of active research and discussion among scientists. The causes of this phenomenon are not fully understood, and many specialists link it to limitations of the data used to train the models, suggesting that systems are not always capable of adequately responding to certain types of input signals. Others point to fundamental limitations of the model's architecture itself, which may struggle to process information at scales beyond their designed capabilities. There are also those who believe that computational limits have been reached, and that despite their complexity, systems are no longer able to maintain stable and coherent behavior. Regardless of how these failures are explained, the effect observed is astonishing in its universality. It manifests equally across a wide variety of models, regardless of their architectural features or implementation methods. This phenomenon appears to be evidence of a broader pattern. Modern artificial intelligence systems, especially those that are advanced and complex, have their own threshold levels that play a crucial role in their functioning and development. Within such systems, there are hidden mechanisms and types of failures that we often know very little about or do not understand at all. These systems possess internal states and processes that remain beyond our full comprehension, as they are not always obvious or visible to an external observer. For a long time, these systems can operate quite normally, seeming fully functional and stable, until a situation arises that causes their breakdown or failure. In other words, external stability does not always indicate internal harmony or correctness, since processes may be occurring inside that remain unnoticed until a certain critical level is reached. Now, let's examine in more detail how all this relates to a broader and deeper concept called the 3IATLAS, as well as to phenomena of anomalies in general. The consequences of such internal processes and hidden failures can sometimes be surprising in their unpredictability and scale. Any system, whether natural or artificial, biological or technical, mechanical or electromagnetic, has an internal state that is often invisible to external observers. It may appear perfectly normal, operate without failures, and seem stable from the outside, even though tensions, stressful situations, or internal dysfunctions may be accumulating inside. Such a system, despite external calmness, can maintain an illusion of stability until it reaches a certain threshold, after which a failure or unusual behavior suddenly manifests. This is similar to a situation where a person feels good externally, but internally accumulates stress that can suddenly lead to a crisis. In the case of complex systems, whether artificial intelligence or spacecraft, the situation is analogous. For example, when considering advanced technologies like the 3IATLAS concept or related projects, one can assume that these systems also have internal states invisible to us. They possess certain operational thresholds and parameters that are often impossible to measure directly. Beneath their external layer lie internal processes, systems, and algorithms that operate unnoticed by our instruments and diagnostic methods. From a distance, such systems may appear as a single whole, a single object, fully controllable and stable. However, their actual internal structure may conceal entirely different mechanisms, heterogeneous and complex, beyond what is visible from the outside. This is where the main danger lies. The collapse or failure of an artificial intelligence model, in a certain sense, becomes a metaphor and a warning, as it reminds us of how complex and unpredictable systems can become once they reach a certain level of development. The more advanced they are, the higher the likelihood that they will start to behave strangely, deviating from the expected scenario. The internal mechanisms of such systems may contain types of failures and behaviors that cannot be foreseen or predicted with certainty in advance. They may appear to function perfectly until the moment when internal tension reaches a critical point, resulting in a sudden breakdown. This is especially important when assessing whether the 3IATLAS, or any other similar project, is a product of natural origin or artificially created. If we assume that 3IATLAS is a high-tech development, an artificial probe, or a spacecraft sent by another civilization, the principles of its operation and internal mechanisms remain the same. Such systems, regardless of their origin, will have internal states and parameters that are difficult or impossible to measure directly. As a result, our attempts to understand them will resemble blind guessing. We will only observe external manifestations and outcomes, without access to their internal architecture or logic of operation. It is akin to trying to understand how a complex computer algorithm works by only observing its output data, without knowing what happens inside, without seeing the source code or hardware on which it runs. In this context, the emergence of a failure from our perception can only be observed as a final effect. We see a sudden eruption, an activation event, a burst of solar energy that unexpectedly exceeds normal levels. We can document these events, record their chronology, and note the moments of their occurrence and development. However, we remain completely unaware of what was happening inside the system at that very moment. What exactly caused this sudden transition from a state of rest to one of intense activity? We cannot look inside the mechanism itself to understand the internal processes that led to such a shift. It is similar to observing the collapse of a complex artificial intelligence system. We see that something went wrong, that the system's outputs become inconsistent, that its actions turn into meaningless chaos. But the causes of this failure, the internal reasons behind such unexpected changes, remain a mystery to us. We can only record external signs, visual, signal-based, behavioral, and draw conclusions based on them, without access to the internal mechanisms. A broader issue underlying the phenomenon of artificial intelligence stability is an important warning about the need for humility in the face of the complexity of the systems we work with. We must perceive this as a serious challenge, since these are systems that have proven to be much more complex and powerful than we initially assumed during their development. The technologies we create begin to behave in ways we did not anticipate and sometimes surprise us with their unpredictability. We encounter mechanisms that possess hidden aspects of behavior, unexpected failure modes that could not have been foreseen in advance. We develop systems capable of exhibiting behavior that goes beyond our original assumptions and models. They astonish us with actions and outcomes we could not predict, even though the code and architecture of these systems are fully accessible to us, and we understand how they are structured. When it comes to systems we have created ourselves and invested our knowledge and efforts into, those designed, trained, and deployed under our control, even then, with complete knowledge of their internal structure, we face unpredictability. And what can we say about systems that evolve under external conditions, in different physical contexts, governed by other laws of nature, created by intelligences that potentially surpass our own? The answer to this question calls for deep humility. We can only speak cautiously and modestly about possible scenarios, as our knowledge and models are very limited. We must acknowledge that our current theories and perceptions of reality are imperfect, and that our frameworks for understanding the world around us are only parts of a larger whole. It is also important to consider that anomalies arising in these systems may not simply be random errors or measurement noise. They could indicate something far more significant, going beyond our current understanding, involving hidden processes and effects that are entirely outside the scope of our usual perception. In this context, the likelihood that systems like ATLAS could represent advanced technological achievements does not increase in absolute terms but becomes more consistent and internally coherent with a structure that takes into account the complexity, hidden failure modes, and internal contradictions as essential features of sufficiently developed systems. Such a system, capable of hiding from our view, operating beyond the limits of our perception, containing internal processes that we cannot observe directly. This no longer seems like science fiction but rather a quite plausible expectation. And while we contemplate the unusual phenomena occurring in systems orbiting near Earth, the complexities and unexpected failures of artificial intelligence, we must also pay special attention to a phenomenon that happens unnoticed and quietly but holds great significance: signals of inexplicable origin penetrating our cosmos. These signals add another important layer to the overall picture, connecting everything. Part 13. Unusual phenomena associated with the malfunction of a quantum satellite and their possible consequences. By the end of 2025, the first reports began to emerge, astonishing and alarming specialists and observers. These reports concerned the appearance of unusual, sometimes simply mysterious phenomena that did not fit into the conventional understanding of the stable operation of satellite systems. The focus was on a satellite designed for quantum communications, the Chinese spacecraft called Zhongmuxi, an advanced development intended to test and demonstrate the principles of quantum entanglement and quantum cryptography over intercontinental distances. This satellite exemplifies modern technology capable of transmitting and processing quantum states of photons in space conditions. It was built with exceptional sensitivity to detect even the most subtle and delicate photon phenomena, those often inaccessible to ordinary instruments or telescopes. The satellite is tuned to detect individual photons, their quantum characteristics, and states, making it a unique tool in the field of quantum technologies. This extraordinary sensitivity allowed the device to record phenomena that previously went unnoticed or seemed impossible to observe. However, over time, the data collected began to cause concern. Instead of the expected stable signals and predictable results, the satellite started detecting strange, anomalous bursts of photon streams, inexplicable noise in quantum channels, and malfunctions in entangled systems that could not be explained by meteorological conditions or orbital mechanics. These malfunctions manifested in very unusual ways. They occurred at specific times and at certain points in the orbit, creating an impression of pattern rather than randomness. These signs indicated that the influence on the device might have an intentional nature. Unlike suspected technological failures caused by meteorite impacts or solar activity, the observed disruptions did not coincide with known sources of cosmic interference, and their nature and modes of appearance suggested the presence of an external signal, possibly modulating or interfering with the operation of quantum systems. Within the framework of theoretical assumptions, such disruptions could not have been caused by ordinary reasons, such as cosmic rays or magnetic storms, since they occurred regardless of known sources of interference and at unexpected times. Moreover, their appearance and disappearance followed patterns indicating external influence, not random, but intentionally targeted. Specifically, these disruptions gave the impression that someone or something was attempting to affect the quantum states of photons using modulation or interference that could impact the satellite's operation. It must be emphasized that all these considerations are currently based only on hypotheses and conjectures. Official statements from Chinese developers and scientific institutions regarding the nature and causes of the satellite's malfunctions are minimal and restrained. Most of the information received comes from unofficial sources, leaks, and rumors, which, however, do not exclude the possibility of their credibility. If these reports are not fabricated, then a very important mystery may be unfolding before us. We are observing a phenomenon that seemingly links the ongoing astronomical anomalies with potential technological disturbances occurring in space. This opens up a completely new perspective. Perhaps processes or signals are occurring in near-Earth orbit or close to the Earth that can influence our most sensitive instruments and technological systems. Such signals or manipulations could create interference, disrupting the operation of our advanced communication and security systems, as well as causing malfunctions in quantum channels, which are considered among the most secure. This hypothesis leads us to the question of possible interaction with some invisible or hard-to-detect object that, as it seems, is studying or testing our technologies. In the context of discussing cosmic anomalies, imagine that there exists an external intelligence capable of deliberately testing our systems by creating small disruptions and faults. These malfunctions would serve as a kind of test, allowing assessment of our reactions, capabilities, and level of awareness. In this case, the photon bursts detected by Young Musi could be precisely the type of signal or signature that we are more likely to notice. These bursts are nothing more than potential traces or signs of active actions by this hypothetical intelligence, which are intended to be detected through proper analysis. Of course, all this is merely a pure hypothesis, based on certain patterns of behavior and observed phenomena that periodically occur on different scales and in various fields. However, it must be emphasized, this is only an assumption, not yet conclusively confirmed, just an attempt to understand what might be hidden behind the visible anomalies. These anomalies, manifesting across various systems and at different levels, often attract the interest and caution of researchers, as they may indicate possible intentionality. That is, suggest that someone's deliberate activity lies behind them. However, in most cases, the institutions responsible for scientific analysis and security tend to remain silent about such phenomena, and their explanations often appear strained, barely concealing contradictions and unconvincing evidence. Alternative hypotheses for the emergence of these disruptions include a wide range of possibilities, from the effects of space weather and cosmic rays to drift in settings and calibration errors of instruments, from noise in detectors to data distortion during transmission. Ultimately, most researchers lean toward the idea that these anomalies could quite plausibly be caused by ordinary, explainable natural or technical factors. The hypothesis that a satellite encountered unknown, as yet unstudied interference seems unlikely. The probability of this is quite low, and most specialists believe that traditional methods and existing knowledge are sufficient to explain such phenomena. However, the patterns that emerge across multiple systems and observations simultaneously, as well as the coincidences in time with astronomical events, such as those associated with the so-called 3IATLAS, allow us to hypothesize that there may be something much more significant and profound behind all these phenomena. The sequence of these events, their interconnection, despite occurring in different technological contexts and fields, creates the impression that these are not merely random coincidences. In such a situation, the line between solid evidence and manifestations of paranoia becomes very thin and fragile. When individual anomalies appear in isolation, they are easily ignored, attributed to chance or technical malfunction. However, when patterns begin to emerge, when the same anomaly appears in different systems, and when temporal correlations become too precise to consider mere coincidences, such scattered signs start to transform into a potential signal. And once this signal, once recognized and documented, becomes sufficiently clear that it cannot be ignored, it turns into a serious basis for further reflection and investigation. This leads us to the last, most mysterious, and perhaps most crucial anomaly, the final layer of evidence and patterns that connect phenomena related to comets, satellites, and the very structure of the universe into a unified whole. In this context, particular attention is paid to a very important point: the Antarctic region, the observatory called the ice cube, and the signals passing through the Earth itself. Part 14 is the mystery of the hidden signal originating precisely from Antarctica. At the South Pole, deep within the icy layers at the very heart of the continent, scientists have established a unique observatory that stands out among all similar facilities on the planet in its purpose and capabilities. This observatory is designed to detect rare and extraordinary phenomena. When neutrinos encounter atomic nuclei under truly rare and exceptional conditions, meaning situations that happen very infrequently, something truly astonishing and mysterious occurs. Imagine, the thick ice sheets of Antarctica, where temperatures reach extreme lows, become the site of interactions between extremely weak and elusive particles and atomic nuclei. As a result of this rare but critically important event, a small but distinctive flux of secondary particles is generated in the surrounding environment, resembling a tiny rain shower pouring out of nowhere. This flux is a chain of successive transformations, during which primary neutrinos penetrate the ice and collide with atoms, causing their excitation and subsequent decay. These interactions produce faint light, an almost imperceptible glow that permeates the thick ice layer, like a ghostly trace left by an invisible traveler. This faint light, or more precisely, this delicate light signal, is the very indicator by which scientists learn about what is happening. It is this weak, nearly invisible glow that can reveal the secret of neutrino penetration into icy masses, and it becomes a key for specialists to understand the processes occurring inside the Earth and beyond. Modern neutrino detectors, such as IceCube, are capable of detecting this subtle light. They employ highly sophisticated instruments embedded deep within the Antarctic ice, precisely tracking the direction and energy of the originating neutrino. These devices are akin to ultra-sensitive eyes that capture every minute change in light, every movement, and every signal emanating from the Earth's interior and the cosmos. Based on the data collected, scientists draw important conclusions about the origins of these neutrinos and the reasons for their existence. The observatory continuously records all events related to neutrinos, accumulating years of observations and creating an extensive, ever-growing catalog of these mysterious particles, which help unlock the secrets of the universe. This catalog is like a living document, capturing the highest energy events occurring in space and inside the Earth, allowing scientists to see the invisible and understand what previously seemed unreachable. This collection of data reveals the universe from a new perspective, showing invisible travelers passing through us, around us, and beyond us, unseen but perceptible. Most of them are delicate messengers from space, moving through an endless flow that we can only detect but not feel. And so, in this ever-expanding catalog, an unexpected and truly strange element has appeared, something anomalous and astonishing. Researchers have discovered that beneath the icy cover, at depths spanning hundreds and thousands of meters, neutrinos are emerging that move upward. That is, they begin their journey not from space, but from the depths of the Earth itself. These upward-moving neutrinos apparently originate from the planet's interior, from its depths located beneath the detector itself, and travel upward through the icy mass before being detected by the sensitive IceCube instruments. These upward events are extremely significant, and their importance is hard to overestimate because they cannot be the result of cosmic rays. Cosmic rays are particles constantly bombarding our atmosphere from space, creating a shower of high-energy secondary particles that strike the Earth. They trigger a chain of secondary processes, resulting in the production of downward-moving neutrinos, which are the signals most often recorded by IceCube. There is nothing surprising about this. It is a well-known and expected phenomenon. However, upward-moving neutrinos traveling upward are a completely different case. They cannot be generated by cosmic rays because, moving upward, they must originate inside the Earth or its interior. This means that such neutrinos must have local sources within the planet itself, since the energy levels at which neutrinos operate are characterized by a certain stability and consistency. They do not change abruptly and suddenly, as is the case with random and unpredictable noises that can occur in the environment. Instead, the distribution of energy levels demonstrates certain patterns that can be traced in the data, and these patterns are not random. This indicates that there are specific internal connections and structured patterns within the observed events, rather than a mere random distribution. When engineers and scientists design such complex detectors, investing years of diligent work and millions of dollars into creating and calibrating equipment for observing cosmic events, and when they collect vast amounts of data over extended periods, they begin to notice in this data something more than just noise and random fluctuations. Patterns emerge that are difficult to explain using conventional, traditional models of physics and statistics. Consequently, an important question arises: what exactly is creating these signals? One possible hypothesis is that our current models of neutrino origins within the Earth are incomplete or insufficiently accurate. Perhaps we have overlooked some natural source, mechanism, or phenomenon capable of producing neutrinos precisely at these energy levels. In other words, it could be something that has not yet been considered in our theories, something hidden from our usual understanding of the processes occurring in nature. There is a possibility that we are ignoring or underestimating the existence of some natural phenomenon that generates these high-energy neutrinos through mechanisms that remain a mystery to us for now. It is quite possible that the origin of these signals lies in unknown physical processes occurring deep within our planet or beyond its boundaries, which we have yet to explain. Another, no less important and controversial hypothesis is that these signals may be the result of rare but entirely natural events, random emissions from natural sources, that fall within the scope of our models and theoretical frameworks. Perhaps we are observing something that initially appears as an anomaly but over time will find its place in expanded and more accurate models. Such events, although unlikely, could explain certain features of the data, and in the future, they might be incorporated into more complex theories that account for a wide range of natural phenomena. However, there is also a more troubling, contentious, yet not excluded hypothesis that makes logical sense and warrants serious consideration. It suggests that the detected signals are not the result of natural or random phenomena but indicate an artificial origin. In other words, it could be a signal coming from intelligent beings on Earth, or from those beneath its surface, or even from entities somehow passing through our planet. This hypothesis proposes that the data may contain signs of activity related to the creation, generation, or transmission of high-energy neutrinos, which are byproducts of their technological processes or communications. In other words, we might be encountering the result of some form of intelligence using neutrinos as a means of communication or for other purposes. At first glance, this idea seems incredible, almost absurd, which is why it raises many doubts. But it is worth remembering that neutrinos possess a unique property that fundamentally changes our understanding of their potential uses and detection capabilities. This property is that neutrinos can easily pass through any obstacle, be it rock, metal structures, dense layers of atmosphere, or even entire planets. They interact with matter very little, unlike electromagnetic waves, radio signals, or other forms of radiation, which are easily blocked or intercepted by various means. Electromagnetic signals can be suppressed or completely blocked with simple shielding, radio signals can be drowned out or intercepted using special devices, and wireless communications are encrypted. If we consider the hypothesis of the existence of a mysterious object known as the 3IATLAS, it can be assumed that it is some kind of artificial probe or device created not by humans, but by intelligent beings of a different nature. If this apparatus is equipped with advanced technologies that we do not yet fully understand, as well as communication means or operational methods beyond our current knowledge, then high-energy neutrino signals could serve as the most probable evidence of its presence. These signals, resulting from powerful physical processes, could act as a kind of trace of technology left in space. Using such a medium as neutrinos, this probe would have the ability to maintain communication with other objects or stations spread throughout the solar system. It could exploit systems that naturally produce neutrino emissions, such as those generated by energy or industrial processes, which occur as a side effect of electricity generation. In this case, information transmission could be carried out through complex patterns sent as specific sequences of signals, which, if we had sufficiently advanced detectors, we could attempt to decode and understand. The idea of connections between comets, satellites, or even observatories located in Antarctica initially seems overly fantastical. Many scientists perceive such assumptions as far from reality, provoking only skeptical rejection. They appear as wild conjectures, products of an overly vivid imagination, and thus lack support within the scientific community. However, all these claims are merely different manifestations of the same phenomenon, which is difficult to explain with conventional ideas. In reality, anomalies manifest precisely where they seemingly should not, in places where, according to established theories, signals either should not appear at all or their levels are negligible. Moreover, it is astonishing that such unusual signals and patterns occur in data that are inherently supposed to be random. And it is precisely in those areas where traditional science does not expect to find anything unusual that signs of activity emerge. These signs, these signals, appear in points of space or levels of investigation where, according to official scientific concepts, they should not exist. All of this is met with silent approval or, more accurately, with weak reactions from institutions and scientific bodies. All of this is increasingly explained by more complex models that interpret the events through ever more convoluted and artificially complicated theories, which lead us to believe in increasingly unlikely coincidences and randomness. However, all these observations require thorough investigation rather than ignoring or dismissing the specialists who documented them. Evidence supporting the reality of these anomalies exists and has been confirmed by data that are reliably preserved. These data cover vast scales, from comets passing close to Earth to quantum effects occurring in the deepest layers of matter. They encompass everything from solar processes to the Earth's interior, making it possible to construct a comprehensive model. It is time to connect all these elements together, establishing links between them to understand the broader picture. This should be a picture where objects of the solar system, stars, satellites, and the very structure of the universe intertwine. The moment has come for synthesis, to unify all these elements into a single whole to understand how they interact and what lies behind them. This can be called the point of ultimate convergence, when all fragments begin to form a complete picture, allowing us to see a clearer and expanded perspective. The entire meaning of what is happening can be summarized very simply. Three objects move in harmony, as if a coordinated whole. These three objects are seemingly connected and moving with a specific purpose. Their movement reflects three consecutive solar eruptions that occurred in an exact and clearly recorded sequence, which is not a coincidence. When we start to consider all these phenomena collectively, when we do not get distracted by isolated cases but try to see the whole picture, a pattern emerges that cannot be ignored. This approach implies that we do not view random anomalies as separate phenomena but look at their totality, their interconnections, and the overall signal they form. Such an analytical method suggests that events beyond our perception occur simultaneously on multiple scales and levels. Regarding the scales of our solar system, the arrival of 3IATLAS spacecraft and their satellites is either the most extraordinary and surprising coincidence in history or evidence that something deeper is at play. Something intentionally organized and planned. On a stellar scale, the discovery of dark stars, which differ from ordinary luminous bodies in their characteristics, suggests that the universe contains objects with extraordinarily powerful and hidden engines, as well as objects capable of withstanding incredible loads and maintaining their structure over unimaginably long cycles of existence. In the context of artificial intelligence development, detecting hidden failures, collapse conditions, or unusual malfunctions in systems reminds us that complexity itself harbors numerous surprises and unexpected twists. On the scale related to quantum physics and observations at the micro level, the appearance of anomalies in the operation of quantum devices indicates possible interference, failures, or external factors affecting our most sensitive instruments. And on a planetary scale, a signal originating from Antarctica serves as evidence that someone, or something, is transmitting signals from or near our planet. We are only beginning to realize the scale of this phenomenon, its depth, and potential consequences. All these phenomena are not isolated, independent events. On the contrary, they are interconnected, forming a continuous chain stretching through space and time. This entire set of events seems to be a manifestation of some hidden thread that unites all these phenomena into a single whole. This thread is something deeper than just a sequence of random occurrences. It is a complex, multi-layered structure representing the concealed complexity of the universe itself. It reveals that the world around us contains far more mysteries and secrets than current scientific models suggest. And this thread leads somewhere, toward revelations that mainstream science often prefers to overlook. These are not mere coincidences. They pose a challenge to our established ideas and theories. At the core of this entire picture lies a fundamental discomfort that permeates the very essence of what is happening. It is the realization that standard science, at its core, operates on the principle of parsimony, the principle of minimizing assumptions. We tend to favor simple explanations requiring fewer assumptions. We choose natural, obvious processes over artificial or complex ones. We tend to believe that everything happening can be explained without invoking intelligent forces or intentions. This principle, known as Occam's razor, has long served as a reliable guide, helping us avoid unfounded speculation and false hypotheses. It encouraged us to seek explanations in natural laws and processes before turning to more complex or hypothetical theories. Thanks to this tool, we have been able to greatly expand our knowledge and make numerous scientific discoveries. However, like any tool, Occam's razor can be misused or abused. In certain situations, it becomes not an aid but an obstacle. When we start ignoring or suppressing real anomalies and unusual phenomena, using this principle as an excuse, we risk missing important clues about the nature of the surrounding world. The reason we tend to perceive the hypothesis of extraterrestrial civilizations as possible is not because we are confident in their existence. Instead, it is because all alternative explanations face much more serious logical and evidential obstacles. They require us to believe that every observed phenomenon, every anomaly we document, is merely a coincidence, that all detected patterns are false, and that any correlation is accidental. In this context, the probability that what is happening actually has some hidden, intentional nature is significantly higher than the probability that it is simply a collection of rare but natural coincidences. In other words, we are confronted with a phenomenon that fundamentally challenges conventional thinking. In standard scientific practice, claiming that an anomaly has an artificial origin is considered extraordinary, and requires extremely strong evidence to support it. However, when explanations based on natural causes demand that we accept a chain of incredible coincidences and extend existing models to their limits, the situation changes dramatically. In such cases, evidence pointing to an artificial source of the phenomenon may appear more convincing and substantial than evidence supporting its natural origin. As a result, this hierarchy of usual assumptions is inverted. What was previously considered unusual and requiring special confirmation becomes more probable and explainable, and vice versa. Thus, an extraordinary and mysterious claim gains the status of a more plausible explanation, while previously accepted concepts perceived as natural begin to seem less likely. Convenient hypotheses turn into extraordinary theories that require serious defense and justification. In the coming months and years, based on how events unfold and what new data are obtained, it will become clear whether our analysis is prophetic, capable of foreseeing the future, or merely guesses based on assumptions and hypotheses. The most important and primary indicator in this context is the behavior of the planet Atlas, which is moving along its orbital path and approaching perihelion, the point of closest proximity to the Sun. If we assume that this object is not a natural celestial body but artificial, and that the accompanying objects are also created with a specific purpose, then we should expect an amplification of the patterns already documented earlier. First and foremost, it is reasonable to assume that solar eruptions will become more intense, more frequent, and more precisely correlated with the passage of this mysterious object. It can be expected that manifestations of chemical and polarization anomalies will become more noticeable and pronounced as the object heats up, encountering increased heat emission and stress due to its proximity to the Sun. At the same time, morphological features may become more distinct if the protective coating of this object, let's assume its shell or external structure, begins to break down or become disrupted under the influence of solar heat and energy. If, on the other hand, observations show that the 3IATLAS behaves like any other comet when heated, that is, eruptions cease or become sporadic, and anomalies disappear, this will provide us with valuable information. We will then realize that our initial assumptions and reasoning, based on observed anomalies, were incorrect, and that, in fact, natural processes well known to science are behind this phenomenon. Both outcomes, confirmation of artificial origin and refutation of it, are important. Both scenarios reveal something true about our universe, its structure, and the nature of the phenomena we observe. The second key indicator is the behavior of the data collected during observations. The James Webb Space Telescope is the most powerful. If the data obtained with the James Webb Telescope are immediately published and accessible to the entire scientific community, we can confidently say that the mechanisms within institutions responsible for control and secrecy have not been engaged. In this case, it will become clear how transparency differs from secrecy, and how open scientific activity differs from institutional measures aimed at keeping information hidden. This will be especially evident in how the obtained data are transmitted and disseminated. After all, the understanding of how open and honest the current situation with the study of cosmic objects truly is depends on this. This distinction is directly related to the so-called third important aspect, the issue of providing raw data. In scientific practice, researchers work with FITS files. These are files containing raw, unprocessed observational results, recording every individual photon, measurement, and data point obtained through telescopes and satellites. These files form the foundation for all subsequent analytical work, as they contain the most accurate and complete information. However, these raw sources are often not immediately accessible to a broad circle of scientists and researchers. Within research groups, the files may remain closed, inaccessible to outsiders. Sometimes such data are intentionally classified to prevent the disclosure of secrets or to maintain competitive advantages. In other cases, they are simply set aside and not published until the final and official version of the results is prepared. If raw files with observations of solar activity from telescopes involved in the SOHO project, as well as data obtained using astronomical instruments such as ATLAS telescopes, are made publicly accessible to the scientific community, then there will be an opportunity for objective and comprehensive analysis. If all interested parties, professional astronomers, amateurs, and independent researchers, gain access to the same raw data available to government agencies and space organizations, then, without a doubt, it will be possible to undertake genuine and in-depth investigation. This will provide a chance to verify each hypothesis, confirm or refute theories, uncover new facts, and perhaps shed light on long-standing questions. Conversely, if raw files remain restricted, with access limited to a narrow circle of verified scientists working within strictly defined institutional channels, then it can be confidently said that the information is under control and not intended for broad discussion. In such a case, we cannot expect an honest and transparent investigation, as these restrictions and secrecy indicate an attempt to keep the situation under control, avoiding a full-scale public analysis. The nature of data disclosure or concealment reflects how serious and honest the investigation is. If information is open and accessible, it most likely indicates a genuine, comprehensive study. If data are hidden or their dissemination is limited, it suggests that priority is given to managing information rather than seeking the truth. Moving on to the fourth important aspect, actual intervention and active actions by leading space agencies and scientific organizations. In recent years, NASA and the European Space Agency have discussed projects related to intercepting and studying potentially hazardous asteroids. Such plans involve launching spacecraft to meet near-Earth objects to conduct detailed observations and, if necessary, alter their trajectories in case a collision threat with Earth is detected. A specific example is the proposed Juno mission. This project involves launching a spacecraft that would approach a potentially dangerous object and collect precise measurements and observations in real time, transmitting them to Earth without delay. If such a mission is approved, carried out, and successfully completed for an object related to the Atlas system or other potentially hazardous bodies, we will learn that the scientific community has recognized the importance and danger level of this object. This would serve as a clear testament to the fact that the final, but no less important and defining aspect of the discussion on disclosure and public communication is the very nature and degree of transparency with which government institutions share information about their research, observations, and findings. In the United States of America, there is a special Freedom of Information Act that grants citizens the right to request and access official documents and materials held by government agencies. This law is one of the cornerstones of the democratic transparency mechanism, ensuring that authorities cannot conceal vital information except in cases where disclosure could harm national security, endanger lives, or violate other legitimate state interests. In other countries following a democratic model, similar legal mechanisms exist to ensure openness and transparency of government activities to civil society. However, in any case, when it comes to secret observations, documents related to programs and projects involving the analysis or tracking of unidentified objects or phenomena, complex situations arise involving the balance between public interest and the need to maintain state secrets. If civil organizations, researchers, or individual activist groups initiate requests for such classified data, their appeals may be directed to the appropriate authorities for review. When courts, guided by existing laws, require the disclosure of information, and authorities are compelled to comply, a significant shift in transparency occurs. In such cases, if the data provided and analyses conducted by military, intelligence, or other agencies become public knowledge, people gain the opportunity to form a more complete understanding of what is happening behind closed doors. As a result, there is a chance that the truth, which has remained hidden or inaccessible until now, will come to light, become open, and be available to everyone. However, if such requests are denied, if courts confirm the legality of classification, and government agencies successfully maintain secrecy by concealing information indefinitely, then we can say that the system of institutional control and oversight mechanisms remains unchanged. In this scenario, secrecy continues to play its role, and the official government stance remains unchanged. The outcome of these legal battles, which take place within the framework of ordinary democratic procedures, will determine whether hidden information will ever become accessible or remain forever buried beneath the weight of classification barriers and access restrictions. This process is not merely a legal formality or a procedural conflict, but an important indicator of the transparency and openness of authorities toward society. Understanding how these confrontations will end is directly linked to the future development of the situation and possibly to the fate of humanity itself. If successful and transparent, when secret materials become available, a new chapter in the history of scientific and societal knowledge will open before us. Conversely, if the system maintains the status quo in all its manifestations, there is a likelihood that these secrets will continue to remain concealed, and society will remain uninformed about the most significant events and discoveries. It is the outcome of these legal and institutional disputes, conducted through normal democratic procedures, that will determine whether hidden knowledge and information will become visible and accessible or remain forever buried under layers of state secrecy and restrictions. This dilemma is one of those that attract the attention of researchers like Lowe and others studying phenomena and mysteries related to unidentified objects. It motivates continued serious and in-depth research despite resistance and institutional obstacles. And many wonder, what if these mysterious objects and phenomena are not accidental, and their appearance is connected to some deeper, hidden meaning? What if 3IATLAS is not just a random name or another project, but exactly what Chiagu first reported, and subsequent analysis confirmed his hypotheses? What if it is a reconnaissance probe, specially created and deliberately integrated into our solar system? The question arises, are we being systematically misled by those very artifacts and biased perceptions that surround us from all sides? In conditions where pattern recognition is used, an illusion often arises that we can create a false reality based on our own prejudiced preferences. Such biases, like filters, seek meaning even in noise, random, unexplained changes and disturbances, and sometimes interpret intentions where there are only coincidences. It is crucial to understand that the answer to this question holds immense significance. It will determine how we perceive our own identity, our place in the vast universe, and ultimately, what future awaits humanity as a whole. Today, in a state of uncertainty, the answer remains open and ambiguous. All existing evidence, despite its persuasiveness, points in one direction, but confidence in the final conclusion remains unspoken. Silence and evasiveness from official structures only strengthen our suspicions, fueling the feeling that something much greater is being concealed. However, despite this, absolute certainty remains unattainable. Under these circumstances, each of us, whether a viewer or observer, must become not just an onlooker but an active investigator. It is here that skepticism must give way to genuine curiosity, and the ability to calmly and soberly accept uncertainty becomes the most important quality. Because true understanding will not come from someone passing judgment or declaring a final decision, but from the information that becomes accessible to society as a whole. The truth will reveal itself in the data that is open for study, in the facts that are publicly examined and analyzed, as well as in the refusal of some individuals to meekly accept official silence as a substitute for genuine investigation. It is well known that patterns exist, and deviations from them are documented clearly and unmistakably. The questions that were posed and asked remain, and now it is only a matter of observing how events unfold further. Everything depends on how many people show concern and take an active stance, express their need for answers, and demand transparency. The data exists, observations have been made, evidence has been collected. Now it's up to those who notice these trends not to silence them or hide them, but to share with others, preventing institutional inertia and convenient assumptions from drowning out the voice of reason and truth. The three atlases, like symbols, continue approaching their perihelion, the point of closest approach to the center. The objects associated with this movement maintain their positions, as if on the brink of something significant. Solar activity, according to observations, is noticeably intensifying, and in secret files, as well as in scattered government and space agency data, there is undoubtedly much more information than they are willing to disclose publicly. It remains unclear whether these secrets will ever be revealed willingly or if they will stay hidden forever. The question is, can society achieve the disclosure of this information through legal and political means, or will it remain in ignorance, continuing to live under the cover of secrecy? What can be said for certain? Something is truly happening, something real, tangible, and documented, something that contradicts our usual worldview and our understanding of the universe and our role within it. And the only worthy response for a thinking person is to look directly at what is happening, study it without fear, demand explanations, and not submit to the institutions that profit from our ignorance. The truth is somewhere nearby, and contrary to what was shown in old TV shows or movies, it does not hide in the shadows. This is evident from our data, documented in our observations, and it awaits the moment when we summon the courage and resolve to see it in all its grandeur.